Hey everyone, welcome to the Drive Podcast. I'm your host, Peter Attia. Well, Andrew, awesome to have you here again, but this is the first time we're going to sit down and do something formal about it as opposed to just play patty cakes in the garage.
Great to be here. I always enjoy seeing you. I always learn from you. And when I train with you, I always enter a new pained state, like this morning with the blood flow restriction training.
Yeah, so how did you enjoy that? Just, I guess, for listeners, what did we do? We put you had done a pretty big workout. You went for a run.
I hadn't yet gone for a run. I hopped on the assault bike and was just pedaling and warming up. Then I started doing some intervals of pedaling harder.
Yeah, looked like you were working hard.
Yeah, and then I hopped off and was headed out for a run. And you said, let's put the blood flow restriction cuffs on and give you a little workout. And I thought, we'll do it like last time and put them on my arms. And I've done that workout before. We do some curls with a lightweight with the blood flow restriction cuffs. And those were extremely painful in the past. This time putting on the legs was less painful in a localized way. It was more of a whole body pain. So it was more distributed, but pedaling for 2 minutes at 220 watts with the cuffs on my thighs, you don't feel like your legs are going to pop. You feel like your whole body is a little bit swollen. But then when you come off of that 2 minutes and you take the cuffs off, I can't really describe the feeling, but it's somewhere between bliss, relief, and a supercharge. So I took off for a run, I think feeling more energized than I had in a long, long time.
Yeah, I do what I had you do today. I do that 2 to 3 times a week at the end of a leg workout. And you're right, it's very different. There is something about the BFR cuffs on the arm. And I suspect it's because there's less fat here and it's easier to compress the vasculature. So you get more distal occlusion. Mm-hmm. But I agree with you completely. Like doing bicep curls with those cuffs on it is really the definition of hell. And it's much more of a deep, awful pain in the legs. But anyway, I'm glad you enjoyed it.
Yeah, I did enjoy it. I've noticed, because I've now done the blood flow restriction training 3 times, today being the 3rd, that when it's done on the upper body, the pain can be very localized and it starts to migrate around in interesting ways. I think I've actually learned a thing or two about the distribution of sensory receptors in the upper body. Immense pain in the hands, for instance. And then the moment you think you can't tolerate it at all, it migrates to your shoulder and away from the hands. And again, with the legs, it's more evenly distributed. But I think as long as people don't try and cowboy it and just tie tourniquets, which would be you need the proper blood flow restriction cuffs, obviously. I think it's an incredible training. Can you just remind me what some of the benefits are? Growth hormone increase for sure. Minimal soreness despite getting quite a lot of metabolic
it's
activity.
Basically less trauma with more sort of metabolic benefit as well. So one of the reasons I like doing the set I had you do today is I like exposing my legs to lactate, right? So the more lactate you're exposed to, the more MCT the cells will upregulate. So basically you want your cells to become more and more efficient at taking lactate and getting it out of the cell. And ultimately, right, lactate's an amazing fuel. I mean, you probably know more about its role in neurons, which I think is just starting to become appreciated. We've typically thought of neurons as only accepting glucose and ketones, but I think there's emerging evidence that lactate is a fuel. And then, of course, the liver can turn lactate right back into glucose via the Cori cycle. So I think the more efficiently our cells can get lactate out and start processing, it's not a poison as I think we once thought of lactate as kind of like a bad thing. It's not. It's bad if you don't know what to do with it.
Yeah, my understanding about the distribution of neurons that preferentially use lactate as a fuel under conditions of, let's say, high stress, but also just high exertion, doesn't have to be stressful, is that for somewhat obvious reasons, the hypothalamus and areas of the brainstem that control breathing and more primitive functions are going to utilize that fuel preferentially first. And this is actually evident when, for instance, you get into an ice bath or any kind of adrenaline shock environment. What little neuroimaging is out there tells us that the prefrontal cortex, which is involved in kind of rule setting and decision making, but really rule and contingency setting, we could talk more about this, essentially shuts down, but doesn't shut down because of lack of electrical activity. It shuts down because there's a preferential shuttling of glucose and lactate to other regions of the brain that just need to keep everything online. So you get into the ice, translated to plain English, you get into the ice bath, you get the shot of adrenaline, or you get the shot of adrenaline from anything, seeing a car crash or getting a troubling text message. And essentially your forebrain quiets for about 20 to 30 seconds. And all the other systems kind of ramp up in terms of survivability functions. And then forebrain can come online. I think that a lot of people feel hijacked by the autonomic response associated with hypothalamus and brainstem activation. Heart rate goes up, breathing goes up, pupils dilate, tunnel vision. All of that happens immediately. And I think most people aren't familiar with those states. And the more familiar we can become with those states and the fact that they are indeed transient, the lower the probability we get hijacked by them. So this is classic stress inoculation, but it's nice to see that nowadays a number of people are doing this outside the military and outside of sports training and just teaching themselves to be comfortable with that pulse of adrenaline and doing it through deliberate cold exposure or the blood restriction cuffs. I think once you feel that first shot of pain, like how am I going to make it through 2 minutes of this? That's another place where you just keep going and then all of a sudden your brain comes online. The forebrain comes online.
Yeah, that's interesting. So basically, for a lay person like me, when it comes to the brain, we basically evolutionary have decided that the most advanced part of the brains we can basically sacrifice temporarily for midbrain, brainstem, all of these things that are absolutely essential. And so it's basically a shunting of resources away from a somewhat gratuitous part of the brain that is the most evolved.
Yeah, and I think when I say things like the forebrain shuts down, I'm using a broad brush.
Yeah, you just mean less resources are available for it.
I mean, one of the more powerful set of discoveries in the last few years, it comes from a colleague of mine at Stanford, Nolan Williams, who's in psychiatry and neurology. And I think the simplest way to think about it is the following: the prefrontal cortex, the brain real estate right behind the forehead, is really involved in rule setting by context. So, there's this classic Stroop task. You give people a bunch of cards with words or numbers written on them in different colors, and then you ask them to read the words or the numbers. It's pretty straightforward. Or you ask them to tell you the colors and ignore what the words say. Sounds easy. Actually, it's very hard to do when going fast. And then you start switching back and forth. That is a very prefrontal cortex dependent kind of task. And what does it reflect? It reflects the ability to adjust your rule set depending on what's demanded of you in the context. So when I walk in here for a podcast, very different rule set in context than when I'm alone at home or when I'm public speaking or whether or not I'm podcasting, right? Slightly different rule sets, being a guest versus hosting a podcast, but completely different sets when you're spending time with your children, your wife alone. So rule setting and context is completely governed by prefrontal cortex. Hence the famous case of Phineas Gage, who caught a tamping iron, destroyed his orbitofrontal prefrontal cortex.
Why don't you tell that story? It's such a great story that everybody learns in neuroanatomy.
Yeah, so this is a classic story in neuroscience. And I should just mention that because I know that many people out there, especially in the Twitter sphere, are obsessed with clinical trials, and clinical trials are wonderful and are immensely powerful. But we have to remember that in medicine, and in particular in neuroscience, most of what we know, for instance, about memory comes from one single patient, HM, the famous HM who had bilateral hippocampal damage. That's they deliberately burned out his hippocampi to offset epilepsy, temporal lobe epilepsy. In the case of Phineas Gage, it was a naturally occurring lesion. He was a railroad worker, and they would drive these tamps in with explosives, and he caught one coming up through the base of his jaw. It went out through the forehead, somehow missed the critical vasculature, and he survived. So this thing literally shot out the top of his head, and he survived. And thereafter, he became somebody who did not obey rule sets, inappropriate behavior. He wasn't necessarily profane, but he didn't behave correctly for the context. Whereas before, he was very well-mannered and he adjusted his behavior according to context. When he's out with beers for friends or working on the railroads, he might speak and behave one way, go home, speak and behave another way, etc. Completely lost the ability to switch rule sets according to context. So classic case, his skull is preserved. There have been a lot of rumors about his behavior that are somewhat correct and incorrect. There's also, for example, just one more thing. This was actually a lyric in a Bob Dylan song, Kluver-Bucy syndrome, a syndrome which bilateral damage to the amygdala, which many people think of as involved in fear, but it's really a defense and kind of alertness system in the brain is what the amygdala is really involved in. And monkeys or people who have bilateral amygdala damage, they can still experience certain kinds of fear. For instance, you drive up CO2, carbon dioxide in their environment, or make them breathe pure CO2, they will panic, but they become unafraid of things like snakes, if previously they were afraid of snakes, and they become kind of sexually and food inappropriate. So they'll pick up a pen and start to gnaw on it, maybe taste it. Normally we don't try and taste inanimate objects. And the monkeys would try and copulate with various inanimate objects. And so there's this kind of bizarre lack of context. And believe it or not, even though we think of the prefrontal cortex as this very evolved structure, it is intimately involved with the so-called limbic pathway. It's actually what we call monosynaptic.
So it's less evolved than the top of the cortex, the neocortex?
Yeah, it's kind of interesting. You know, the whole dating of cortical areas is a little bit of a controversial thing, but beautiful work by Arnold Krigstein at UCSF has focused on this using actually carbon dating. As a way to approach this.
How would carbon dating help in that?
Yeah, so they've looked at brains from different species, and they're starting to, establishing homology from, say, a macaque versus a baboon versus a human, humans from different, the thing about, I should just interrupt myself and say that the thing that's hard about studying the nervous system is that there's, in terms of homology and evolution, is there's no fossil record.
Right.
Like the skull is preserved, but the brain essentially degenerates and disappears. So you dig up some bones and there's nothing there. And the two ways that you establish homology actually come from development. One is developmental position. In general, when you look at two different brain areas, like let's say the hippocampus, an area associated with memory, in a mouse versus a human, in the mouse, the hippocampus is up near the top of the brain. And in a human, it's down near the bottom. And you say, well, how can those be the same structure? But if you look during development, they start off in the exact same place. It's just that the human brain, because it has so much neocortex, the outer shell, the whole thing starts moving and moving and moving, and it ends up down in there at the bottom. The second criteria for establishing homology between species of a given brain area or neuron type is connectivity. And so we know, for instance, that the prefrontal cortex and amygdala are monosynaptically connected. There's just one connection, because ultimately everything is connected to everything, right? You and I are related through some distant lineage.
Wait, let me make sure I heard you correctly. You're saying that between the amygdala and the prefrontal cortex is one synaptic connection. That's it. It doesn't go through a network.
Correct. If we were to put a anatomical tracer into the amygdala or to the prefrontal cortex, you would see direct connections between those two structures, and you would see connections with intervening structures, because of course, ultimately everything in the brain is connected to everything. It's just like on Google Maps, everything is connected to everything, even if by way of ocean. The presence of a monosynaptic one connection or direct connection, or even a disynaptic where there's an intervening connection, but only one, it is an important criteria, because what it really says is that it establishes very fast communication between structures. And, the brain is so metabolically demanding in general that, here we're making up just so stories, but we have to assume that evolution doesn't and did not introduce a lot of extraneous wiring. So when we think about prefrontal cortex, we think, oh, there's this, executive function, complex rule setting, contingencies. It must be very evolved. And indeed, it's the region of the human brain that's expanded relative to other primates and other species. But it's involved in some primitive stuff as well, not just by way of connectivity. And this kind of brings us back to the Nolan Williams discovery and point, which is that I don't want to throw out a ton of nomenclature here, but we've got prefrontal cortex for this rule setting and contingencies. You've got things like the amygdala and associated structures. They're kind of threat detection, but are kind of generic. They raise heart rate, they raise awareness, they change the visual system, and they tune your auditory system to localize things as opposed to paying attention to everything in your environment. Imagine kind of a cone of attention at the so-called cocktail party effect. You're trying to hear a conversation in particular, not listen to just the buzz and the clinks of the glasses and stuff in the room. Okay, but also in that circuitry, with involving prefrontal cortex and amygdala, is an area of the brain that is becoming more important to neuroscientists all the time, and especially to clinicians, which is the insula. The insula has a map of the body surface and the internal organs, and is essentially controlling, at least in one region, interoception, which is our perception of everything that's happening within our body. Our perception that our heart rate is increased or decreased, our perception that our blood pressure is dropping, our perception that our gut feels acidic or full or empty, etc. All of the visceral organs are mapped there. And it also,
what's the physical size of this region?
oh, that's a great question. The amygdala, the insular cortex, is fairly expanded in humans, meaning I'd have to check, but it's going to be larger than a few millimeters, which in neural real estate.
Wait, this is a sub piece of the amygdala, or
this is a separate structure, the insular
distinct.
cortex. Yeah.
Okay.
But that's a great question. I'd have to go check the measurements. It's small, but it contains a complete map of the internal body surface. And it's in a position, this is really cool, it's in a position to integrate information about the outside world and rule sets and internal state, and they all converge there. Now, under conditions where we are rested, we are feeling rational, we understand the environment, we feel in control of things, the prefrontal cortex leads activation of the amygdala and the insula. In other words, I can say, okay, my heart rate's going up a little bit, but I've done a podcast before. I can get comfortable here. Okay, someone who's never done public speaking, however, if they get out on stage and they're feeling their heart rate going up and they're thinking, oh my God, I'm going to pass out, or I'm going to say something ridiculous, and they're panicking. What happens there? Well, Nolan's lab and others have shown that now the insula activity and the amygdala starts leading the rule set of the prefrontal cortex. In other words, the coach now becomes the player, right? The trainer becomes the trainee. So it's literally an inversion of instead of it going prefrontal cortex leads insula leads amygdala, it's insula and amygdala lead prefrontal cortex. And so the prefrontal cortex doesn't shut down completely under conditions of, say, getting into an ice bath or panic. The prefrontal cortex can only access one or two very specific rule sets. You lose flexibility of thinking. And this is kind of a duh when you hear it, but I think the fact that neuroscientists are finally identifying the underlying neurology is very exciting, because what we're talking about is that neural circuits can run in both directions. And we had always thought it was, okay, this activates that. It's kind of a chain of events, but it can run in the other direction too. And this is why, for instance—
And sorry, just to make sure I understand, because I apologize for my ignorance on this. You're saying that the action potential moves in the other direction and the neurotransmitters are actually released on the other side of the synapse?
No, I'm so glad that you asked this question. No,
they have two versions.
All these structures are reciprocal.
They're in parallel.
They're reciprocally connected. That's right. So we haven't changed anything about the underlying cell biology, about the axon propagating down the axon. Okay. The action potential propagating down the axon and transmitter release. It's just that it's a two-way highway.
Yeah.
And suddenly, if everything was running north to south, when we are in our rational mind, creativity, all of those things under conditions of calm, as soon as a certain level of internal discomfort arises, everything starts running south to north. And I think that's exceedingly interesting, because it means, first of all, it means that neural circuits are not just, all the classic lesion data. You lesion a structure, like you remove some prefrontal cortex, like the Phineas Gage example, and you can start to see why, that's a cool, naturally occurring experiment. I mean, unfortunate for him, but cool for the world, because we learned. But it's not a great experiment, because you're just getting an impression of what happens when you blow up one city along this map. Yeah. Right? It doesn't tell you anything about the direction of flow of information in and out of that map. And so the more we learn about prefrontal cortex and these other structures like the insula, the more we start to understand that the brain has neurons, of course, and we have what are called receptive fields, which are, basically the way in which specific neurons are activated by specific events in the world, either in our bodies or outside our bodies, but that those receptive fields are very dynamic depending on context. And that the brain, while it has all this diversity of response, it's not infinite. We have modes that we sort of fall into bins of when autonomic arousal, that is levels of alertness, it doesn't always have to be stress. I mean, in the context of say sexual arousal or hunger, the rule set becomes very, very narrow, right? It's find food, it's have sex, it's find a safe place to fall asleep. Whereas when we are rested and we have our basic needs met, whatever those may be, then opens up the opportunity to start thinking in new and novel ways. You can think, oh, it's sort of like the Stroop task on, taken to the extreme. It's, okay, we're 2023, what is the metaverse going to look like? What's Twitter? What's going to happen to Twitter? What's going to happen to the economy? What's going to happen to public health? Is there going to be another debacle with, public health communication as it was over the last few years, et cetera. And so you can start thinking in the way, what you can start doing is combining different rule sets and evaluating those different rule sets. And this, I believe, is one of the reasons why many people experience their best ideas from doing a lot of structured thinking, but also from, taking a walk and all of a sudden an idea comes to us, or in the shower, or when we aren't focusing on the implementation of a specific rule set. It's very clear that the prefrontal cortex has this ability, depending on what else is going on in our body, to sort of start swirling and combining these different rule sets. And I know you and I are both fascinated by high performance, you with F1 and a number of other things, I in some other domains, but there's this sort of classic laddering up of, unskilled is the start of any, of performance, then skilled, then mastery, and then this thing that we love to observe, which is virtuosity, which is this combining of rule sets in a way that it seems even the performer didn't even realize was possible. Anyway, I've transitioned to a number of domains, but at the very least, what this whole prefrontal cortex, insula, amygdala circuitry is teaching us, again, mainly through the work of Nolan Williams, this is not work from my laboratory, is that when people are in states of calm, and certainly in states of what we consider mental health, things run north to south, prefrontal cortex downward. When people, for instance, people who are depressed have deficits in activation of, in particular, the left dorsolateral prefrontal cortex, and much of their thinking and their life is run from the insula and amygdala up to the prefrontal cortex. And this is why people, they believe, wake up thinking, I don't know how to accomplish anything today. There's no point in trying. Their rule sets seem like they don't work because they are only able to access specific rule sets of thinking. And so the rest of us say, well, hey, get some exercise and go for, apply for a job, look for a new relationship. But their rule sets are not available to them. It's almost like they can't see the playboard in the same way. And so Nolan's lab has been using, for instance, transcranial magnetic stimulation to activate, not inhibit, but activate left dorsolateral prefrontal cortex in particular, and seeing that all of a sudden people are starting to, truly in the moment, new ideas about rule sets are revealed to them. And
is the idea there that if you stimulate and activate and send the current back north to south, it automatically reduces the south to north, or just overwhelms it?
Most likely it overwhelms it, and with time creates neuroplasticity that reduces it. And the way it seems to do that is by temporarily shutting down people's interoception. We think so much about get connected to your body. It's so important to be connected to your body. And indeed, many people, their entire life and experience exists from the neck up and the waist down. But interoception is a double-edged sword. It's also been shown that people who have extreme levels of interoception, actually one can know. If you can reliably count heartbeats without taking your pulse or using a heart rate monitor, chances are you have pretty high levels of interoception. This can be trained up.
Wow.
Yeah, some people
I don't think I could guess my heart rate based on my external cues. I'm probably at 60 beats per minute now, because I'm higher than fully at rest, but not much.
But can you feel your heartbeat?
Absolutely not.
Some people can feel their heartbeat, and it's been shown they have very high levels of insula activity. And in particular, there are subregions of the insula. If I said amygdala a second, I apologize. I meant insula. There are subregions of the insula that are particularly sensitive to internal state. Other regions of the insula are tuned to other things.
And just to be sure I understand this, look, anyone who's ever had a, GI bug or something, or God forbid something worse, like, had been extremely constipated or had a small bowel obstruction, like the innervation of the small bowel in particular is insane, right? Like, we are really able to detect pain at even a modest amount of stretch. Just to be clear, are you talking about that pain is perceived in the insula?
That's right.
That's part what you're saying.
Yeah, that's going to be a primary site for delivery of somatic sensation to the brain. Oftentimes people say, the body contains so much information. I have to say, I'm very, very open to the idea that the body plays an important role in all things health and perception. But there is something particularly important about the real estate in our skulls.
Yeah, so this is kind of where I want to go.
You could amputate all 4 of my limbs, and that would suck for me. but I'd still be Andrew. If you take out 1 square millimeter of my prefrontal cortex, who knows, maybe I'd be a nicer guy, but chances are I'm going to be a very different person. Now, that is not true if you remove 1 square millimeter of, say, a different brain area. And I could think of a few where if you put a gun to my head and you force me to do that to myself, I'll tell you one thing. I'll say the last place I would ever allow you to take a square millimeter of neural tissue is my neural retina, because there, you take 1 square millimeter of
That's interesting. I would have guessed hippocampus.
No, there are a few things I'd like to forget. I might ask where they're mapped and then have you delete there. Okay. But in all seriousness, I think the neural retina would be the last place. I guess the peripheral retina, I don't care so much about being able to see out here in my periphery, although that's what you use when you're driving. A lot of people think you use foveal vision, central vision for driving. I hate to tell you this, but there are many people out there driving around right now who are legally blind in their central vision. Are they great drivers? No. Are they decent enough drivers to pass the driving test? They are. So there are a lot of blind people, legally blind people.
In other words, you're basically saying you would prioritize vision over any other part of your brain?
Absolutely, except perhaps motor cortex. Because I could handle missing one eye. But if you look at the allocation of real estate in the human brain, it's very clear that vision and movement dominate most of the requirements.
Yeah, so it's interesting. Movement, clearly, if you look at the sort of the movement cortex, also sensation though. I mean, the homunculus is enormous, right? Remind me how much real estate. I know the occipital cortex is responsible for vision, just on a neuron basis as a percent of total neurons. Is that the right way to think about it?
Yeah.
Or would you also include the glial cells?
Well, in homage to Ben Barris, the great Ben Barris, my postdoc advisor and your former instructor.
Yeah, we're going to talk about Ben shortly.
We should include the glia. Otherwise, the glianistas are going to come after me. But glia obviously are very important cells. But if you were to just say strict, volume-based real estate, and you were to say, okay, how much of the human brain is allocated for vision and vision only, but also how much of the human brain includes neurons that are responsive to visual stimuli. So these might be areas of your auditory cortex that are also responsible for vision. Because of course, if you hear something over to your left, you tend to look over to your left. So there's integration. They're multimodal, what we call multimodal neurons. They have auditory and visual receptive fields. They can be activated by auditory and visual cues. You'd say 40+%, probably 40 to 42% of the human brain has visual response specificity. Incredible.
This is amazing. You've probably heard me talk about this before, but one of the things I enjoy about bow hunting is the ability to observe other species and how they have different superpowers from us. So anybody who's ever been out there with a bow trying to, get an axis deer or an elk will tell you their hearing is incredible, but their sense of smell is next level. We don't have a way to comprehend it. I once heard, it might have been Michael Easter, I don't remember, but an author, no, it wasn't. It was actually, I don't remember. Anyway, someone once gave this amazing description, which was they were out walking and they came across a carcass that was, I forget what the animal was. It was like some animal that had been killed by another animal, but it was mostly still there. And it was rotting and it was rancid beyond words once they were within like 10 feet of it. And the analogy they used is, this is what we smell like to an elk a mile away.
Oh, that's such a great way to put it. Because we always hear, sharks can smell a drop of blood in the water from a mile away, but it's hard to think about that.
It's hard to imagine what that is.
Yeah, it doesn't translate to our own map of experience. I have to mention a book, which is a wonderful book that, frankly, I was a little pissed when it came out. In the best of ways, because I always wanted to write.
It's the book you wanted to write.
It's the book I wanted to write, because animals and animal behavior and perception is one of my favorite things to think about. But there's a beautiful book written far better than I ever could write by Ed Yong, who's a wonderful science writer, called An Immense World, that just came out, which is all about the sensory specializations of other animals. I think you'd really enjoy it. I'd
love to read this.
Yeah, I'll send you a copy.
Yeah. And my point is that the only sense that we seem to have to rival animals is vision. In fact, yes, we actually have better vision than a number of animals because we are tricolor, right? Most of them are two. And so there are some animals that certainly see better than us. I think a lot of the sheep species can see things at a mile that we can't fathom. But I think we probably see better than deer and elk, all things equal. It's just that it's still, their ability to smell and hear us is so much better. So it's interesting to think that much of our real estate is assigned to vision, whereas, what's the olfactory neuronal component? It must be nothing
minimal
for us.
In comparison, which doesn't necessarily, I should just say volume of real estate
is not always the best indicator.
No, in fact, there was a lot of mistakes made in the early days of neuroscience because of looking at the number of neurons or the number of connections. A good example would be the raphe nucleus of the brainstem manufactures serotonin, sends an enormous projection to the circadian clock of the hypothalamus. And there have been dozens of experiments evaluating the role of serotonin in that pathway and its ability to shift the circadian system. And thus far, it seems like barely any influence. Who knows what it's doing? We assume it's doing something, but it's not doing anything obvious based on the experiments that have been done. To be a little careful in any description about animals and the natural world and vision, because this could end up being a 15-hour podcast. Like I turn into the 6-year-old version of myself. Literally my parents took me to a psychologist because they were worried I was spending so much time learning about animals and the natural world. And then I used to come into class and I used to go into kindergarten and first grade and ask if I could give lectures about that. It was an absolute obsession.
So should I be worried about my 5-year-old who feels that way about dinosaurs right now?
No, he would probably be a paleontologist someday.
That's what he thinks.
So. We will get into backstory, but I still feel a full body lift when we start talking about retinas and animals. And so if you'll indulge me, there are a couple points related to what you said a moment ago that I think most people might appreciate just in terms of calibrating themselves to these sensory experiences, because I love the example you gave. We'll get back to olfaction in a moment. But to get a sense of how well we see relative to other animals, if you were to hold out your thumb at arm's distance, if I were to draw 60 black lines separated from one another on your thumbnail,
okay,
you would be able to perceive that. And we call that being able to measure 60 cycles per degree, cycles of black, white per degree of visual
because
angle.
At one arm length, that is 1/360th.
Yeah, that's about
a degree.
1 degree. About 1 degree. It's about 1 degree of visual angle. You have to take into account the optics of the eye.
Yep.
If I were to draw 80 lines.
And sorry, just to be clear, when you say you put 60 lines on my thumb, I can't count the 60. I just recognize that they are discrete lines.
Exactly.
Okay.
Beautifully put. So most people with 20/20-ish vision or with corrective lenses or with LASIK can see 60 cycles per degree. Some people are better, fighter pilots, et cetera. Someone
might be 65,
yeah,
whatever.
Exactly. Okay. A raptor bird of the sort that I saw this morning here in Texas, like a red-tailed hawk or red-shouldered hawk, sees at 120 cycles per degree. So that means they can sit up on a light pole and look down at the ground and see a small gopher raise its head in the ground. And it will look like they'll perceive it. They might not be able to count the whiskers on that gopher's face, but they'll be able to perceive that movement. Now, this is interesting because we have a pupil. We have a fovea behind that. A fovea is just a concentration. A fovea actually means a pit, but a concentration of retinal cells that allows us to see at highest acuity in the central vision. How do we know this? Well, you can put your hand out to the side and your fingers are waving off in your periphery. For those just listening, I'm just putting my fingers off to the side of my head while looking at Peter. And I can see that they're moving, but I can't really count them. If it wasn't my hand, I wouldn't know how many fingers were there. As I move my hand more toward in front of my face, I can count them. So central vision, we have more pixels, if you will, than in peripheral vision, but only in the center, and it's circular. You mentioned sheep, and this is kind of fun in thinking about hunting. Red-tailed hawks have a fovea, but other types of raptors have another fovea that views the floor. So for instance, a diving bird is the best example. Birds that fly along the ocean have a horizontal visual streak that allows them to view the horizon.
Right, so they're what we consider central is their peripheral.
That's right. But they also have a fovea because they need to actually dive into a school of fish and capture a fish while adjusting for the refractory index of the water. Refractory index, of course, is if you ever reach for a coin at the bottom of the swimming pool and you're reaching for it, and it's only when you get very close that you realize you were off by a few centimeters or more. So that's an incredible feat. And they do that by distributing the high pixel region of their retina to a visual streak and down below a fovea. The sloth that hangs upside down has its fovea on the top of the eye so it can view the jungle floor. And there are a lot of examples of this. And my favorite example of this is the J-shaped, it's not really a fovea, but the J-shaped high density, high pixel concentration of the retina of the elephant so that it can view the trunk and the tip of its trunk, because it has to make very high acuity placement of the trunk in order to eat properly. So nature has evolved all these incredible retinal specializations. So animals, and in particular, I know most people are interested in the animal that is us, but animals all have differences in acuity and distribution of what they see in the world. And you mentioned sheep. Sheep actually need to see horizon, but they also need to pay attention to what they're eating, because, you know, they're just mostly like, they're kind of like lawnmowers, right? I mean, but they need to be aware of predators and things of that sort. So a guy down in Australia for years named Jack Pettigrew did tons of beautiful experiments on animals like sheep and goats, and they have incredibly high acuity vision, but for very select regions of visual space. So herein lies the—
Well, you're absolutely right about the horizon thing, because, you know, I have friends that do a lot of, you know, some of the hardest sheep hunting that can be done in North America. And they'll say, I've heard some of them say that out to 5 miles, if you break horizon, you're busted.
That's right.
Can you imagine that? Out to 5 miles, if you break the horizon, the sheep will see you.
And even if they're grazing, they can spot that because of the way that visual streak, it's not straight across the eye, the way it's oriented. So for those of you who want to creep up on animals or people, let's hope for either hunting, which I think is great, or hopefully not. If you're hunting people, let's hope it's within your appropriate professional role, for military. All right. The point being, one universal truth of all of this is that the retina and the visual system is most sensitive to motion. So it's not as if the sheep says, oh, there's Peter and his friends creeping up on me on the horizon. All they see is a deflection of something in their visual field. And there's a very fast pathway that goes from retina to a brainstem structure called the superior colliculus that immediately engages the orienting reflex. It's not even conscious. It's not a decision-making process. It's something comes up in the periphery, something moves in the periphery, and the signal to noise is great enough that we orient towards it, or animals orient towards it. If you watch, for instance, like the Nature is Metal channel on Instagram.
Sorry, do we do that as well?
We absolutely do.
And are we more sensitive to the sound or to something in our periphery moving? Visual
periphery moving. There are exceptions to that, but visual periphery moving. If you like this sort of thing and you want to see it in action, if you go to the Nature is Metal, somewhat gruesome Instagram channel, a lot of examples of lions hunting, and you'll notice the way they hunt. They move very slowly, but when the animal, they learn over time. We don't know what they're thinking, but they learn over time that when they are out of the field of view, or if they are in field of view, they remain completely still.
Yeah.
In other words, the lion becomes invisible when they are not moving, invisible to the prey when the lion is not moving. Now, you could say, well, that's crazy because it's sitting right there. But actually, if I were to eliminate all your retinal movements and you're looking right at me, I would disappear. You're making little microsaccades all the time that prevent the habituation of the neurons that would otherwise erase your visual perception of me.
Wait, explain that more.
So if we think that I see the pen, I see you in front of me, and I can just see it constantly. But the retina has little microsaccades, little tiny, it's jitter basically, that prevents the habituation of the neurons in the visual system from essentially losing the perception of you. If I were, and these experiments have been done, if I were to eliminate these little microsaccades, you would become invisible to me. The only way I would see you is if I moved my head, or I moved my eyes in a bigger eye.
How do you experimentally do that?
So these experiments were done by Huberman Lab and Nobel Prize winners for a number of different aspects of vision. You can do this by giving curare to eliminate the muscle.
The toxin.
Eliminate the small muscle movements of the eye. There's some other drugs that you can use that tap into the cholinergic system.
I see. So you just temporarily paralyze or permanently paralyze these muscles.
Yep. And we're doing this all the time. I mean, now we're getting into the realm of sensory perception, but when my hands are on my thighs,
you acclimate to that.
Yeah, you acclimate, you habituate. Some people call it attenuation, habituation, but adaptation. But you mentioned smell. You walk into a dentist's office. Yep. Oh, the smell of the dental cement, you want to vomit. And a couple minutes later, you're sitting there reading some boring magazine or looking at your phone, and you don't notice it because the olfactory neurons habituate. Because the nervous system mostly runs on a signal to noise over time algorithm.
So the olfactory component is really profound, right? Like you walk into a fish market and you want to puke, and 5 minutes later you've sort of forgotten about
That's
it
right.
and you're looking at the fish.
That's right.
Do we have that profound again, I don't want to use the word adaptation because it's not necessarily the right word, but I think just for people to understand, is there examples of where we have that visually as well, that strong an adaptation?
Yeah, there are a couple of them. I mean, there's rapid plasticity in terms of adaptation. Well, if you go into a funhouse mirror type environment, they tend to change the. That's more of a visual proprioceptive feedback, where at first you feel kind of wobbly, and then you can move. You're like, oh, when I see myself move that way in the mirror, that's not really how I need to respond. But at first you feel a little off balance. There's very fast adaptation of the sort, like you can put in. This is a wild experiment. You put glasses on somebody that inverts the visual world. That's got to throw off your day. But guess what? Within 4 hours, you're navigating just fine. What happens?
What?
This is crazy. The receptive fields invert, and all of a sudden you see the world right side up. Now that's wild.
What? You actually see it right side up, or you just learn that left is right and right is left?
No, it flips, which is crazy.
In 4 hours?
Yeah, about 4 hours or
what
so.
actually happens at the cellular level to enable that?
Yeah, this has been studied by Thomas Poggio and others, and it's still somewhat of a mystery, but this has to do with whether it appears it's bottom-up changes, meaning it shifts in the oculomotor and visuomotor structures of the brainstem, communicating with the higher level perceptual centers of the cortex. Remember, if we were to splay out the from most primitive to most evolved functions within vision, we'd say, and we can make up just so stories of. I always joke, I wasn't consulted at the design phase, so I don't know the logic. By the way, anytime someone asks you, why is something this way, the response should be, I wasn't consulted in the design phase.
I love it.
That's actually a phrase that I borrowed from Russ Van Gelder, who's the chair of ophthalmology at University of Washington. So thank you, Russ. But it captures the fact that, anyone who tells you that they were consulted the design phase or seems to understand why something is arranged a certain way, you can come up with just so stories, but that person might be suffering from delusions of grandeur. So in any event, what we know for sure is that based on genetics and cellular architecture, et cetera, that the primary function of the visual system was not to see and perceive things. It was to recognize when it's daytime and when it's nighttime. Now, we'll get back to this because this turns out to be an important mystery that was solved recently. The neurons that handle this are the so-called melanops and intrinsically photosensitive ganglion cells. They don't pay attention to shapes. They don't pay attention to much, but they tell the brain when it's daytime and they tell the brain when it's absence of light. Okay, this is Sachin Panda, Samir Hattar, all the greats of circadian biology. Matt Walker, this stuff relates to sleep and wakefulness. The next thing is neurons that can sense contrast and motion. More important to me than knowing that like your skin is a particular tone is just knowing that you are there and that you are a moving object, as opposed to stationary objects in the room that I just need to navigate around. Okay, so motion and contrast and motion comes next. Then comes shape and form. Like, is that a fish that I want to move away from, or do I want to approach and eat? Is it bigger than I am? Is it smaller than I am? These kinds of things. And then comes color of the more traditional sort, although I'll return to this interesting thing about color. And then the final category is specific features of shape, such as your face. I recognize your face, or JFK's face, or Marilyn Monroe's face. And indeed,
I like being in the same category as those two really famous faces.
Yeah, there you go.
Yeah, there you go.
As it should be. I mean, there's an area of the brain called the fusiform face gyrus. It lies way up along the visual pathway, meaning very far from the retina. But neurons there are exquisitely tuned to specific faces. In fact, if you lesion that area, people become what's called propasagnosia. Propasagnosia is the syndrome whereby people say, that's a face. I know it's a face, but I don't know whose face it is.
Would that be true if it's their own?
I don't know the answer to that, but it certainly gives them severe deficits in recognizing faces as someone in particular. In fact, Ben Barris, who we both will get back to, had a mild face recognition deficit. I would sometimes walk into his office. He'd say, are you Chala? Chala was a woman that worked in our lab. Now that kind of question might have been more context appropriate given it was Ben, and that will make sense in a few minutes. Ben was transgendered, so that he could kind of, maybe his notions of gender and faces were a little bit intermixed, but we don't think that people who are transgendered perceive other people as different genders. But he sometimes would say, is that Rich or is that Andy? He called me Andy. And or he'd ask Rich if he was Andy. And so the reality is that this brain area controls recognition of facial identity. Incredible, but very high level function.
And just to be clear, there are, extreme examples, obviously a lesion where you can't recognize anybody. But for someone listening to this, there are, I'm sure, people who go to parties and they meet somebody and they say, "Hey, Peter," and you're like, "Yeah."
Yeah. Exactly.
And it's like, "Yeah, we met 3 months ago at so-and-so's."
Right. There are also super recognizers. These people are highly employable by security agencies. Now, the machine learning and AI is getting better than many humans at face recognition. 10 years ago, 15 years ago, retinal scans they existed, but nothing like the ones they have now. Face recognition on your phone for getting into your bank account, it's pretty incredible. But there are super recognizers. There are people.
So there are healthy variants of this, basically.
Oh yeah.
Yeah.
And whether or not it's learned or whether or not there's a genetic component isn't clear. Macaque monkeys, old world primates as we are, also have this fusiform face area. This is largely the work of Nancy Kanwisher at MIT. She's done beautiful work on this. And for years it was debated, is this a face recognition area really, or is it just recognition of, 2 dots and a line? But if I draw 2 dots and a line on a piece of paper, you say that's a face. If I make it curl that line upward a little bit, you say it's smiling. If I turn it upside down or I put it at 90 degrees, it does not look like a face. So the neurons in this area are amazingly tuned to specific features. Now, I mentioned color vision, and you said other animals, like, I hate to break it to you folks, but your dog sees you in kind of a brown, red, orange-ish tones, not in the colors that we see. A mantis shrimp sees 60 different variations of color of red that we can't even perceive. Now, all of that suggests that color vision was a late evolution in the visual system. And indeed, the genetics of the photopigments in the eye that absorb either red, green, or blue, meaning long, medium, and short wavelength lights, not really red, green, blue, argue that's true. And I should just mention while I'm here, you asked earlier whether or not we trait, whether or not our olfaction is diminished. Really beautiful work by a couple, Deeb and Deeb, D-E-E-B, Samir Deeb and his partner, and I can't remember her name, forgive me, at the University of Washington, showed that if you look at the human genetics or genomics, that humans traded out diversity of olfactory receptors, that is the ability to sense a rich array of scents compared to other animals, for evolution of that long, aka red photopigment. So trichromacy is of this ability to perceive in the color ranges that we perceive is a late stage evolution, and we traded out olfactory ability for that.
So the question is, why? Is it literally a real estate question? Is it a metabolic question?
I think, a number of things. Well, first of all, I want to be fair to the olfactory system and the vomeronasal system. I mean, smell is incredibly important for humans. Anyone that got COVID and couldn't smell well for a day, like myself, that sucked. I remember biting into a handful of blueberries and I couldn't taste it well either because it wasn't the cold, it's the lack of smell. Those taste and smell are intermeshed. And I thought, oh my goodness, my life isn't over, but this really sucks. This is not pleasant at all. These just taste like little bags of water, and I love blueberries. Okay, fortunately my smell came back. We are sensitive to the smell of vomit, disgust, I would hope. We are sensitive to the smell of our romantic partners, hopefully not disgust, right? We tend to like that smell. Our kids, yeah. The smell of their heads and in the back of their heads, they produce all sorts of scents. The debate between odors and pheromone effects in humans are present.
What's the definition of a pheromone? Everybody's heard about it, but I don't know the technical
pheromone is a molecule. So hormone obviously is not obviously, but hormone is a chemical released in one location in the body that can act at that location and many other locations, so-called endocrine signaling.
Or paracrine, if it acts right next to it.
Yes, thank you. A pheromone is a chemical released by one organism that can act on the physiology of another organism. Now, there are beautiful examples
and
of
we
this.
capture these. Can we actually say, here is the molecular structure of a pheromone that was released from the nape of my child's neck that I can smell and love?
Okay. The presence of true pheromones, the noun, in humans is still debated because the so-called accessory olfactory system that governs that pheromonal response in other animals there's an organ in the human nose called Jacobson's organ that is thought to be the vestigial pheromonal organ. But so that's debated. But what is absolutely clear is that the scent, right? The conscious perception of that scent has dramatic effects on our physiology. There's a direct wiring from the olfactory system. So this is not pheromone effects, these are odor effects. And those are two different things. So the idea of a chemical coming off of your child and going through the vomeronasal system and impacting these aspects of self-oxytocin release, probably dopamine release, all sorts of wonderful things, that's debated. What is absolutely clear, though, is that that specific scent clearly is perceived and registered by you and has an impact on your physiology.
And if it's not done via a molecule that's traveling through the air, going through the nares of my nose, what is the connection?
So it is a molecule traveling into the nose and impacting, in this case, it would be the deep limbic cortex. You've got 6-layered cortex, which is neocortex, thought to be more evolved. You've got limbic and piriform cortex with the fewer layers, thought to be more, like for instance, the hippocampus, this memory center, is actually it's 3 layers. It's cortical. It's not what we think of as neocortex, but it's very clear from the work of Richard Axel and Linda Buck and others that the smell of your child's head and neck is perceived and impacts specific neurons in these more, quote unquote, more primitive brain areas, and that there are many automatic, innate, as well as learned responses to that. The desire, for instance, to focus off your own needs and focus on their needs. Bliss. I mean, there's no question that those are odor-driven responses. Whether or not they are classic pheromone-driven responses, it's a little bit of splitting hairs. That's where it's debated. And the reason it's debated is that pheromone effects are very powerful in other animals, and you see analogs to them in humans. I'll give a couple of examples, but I do want to highlight that olfaction is absolutely powerful for humans. But of course, you can lose your olfaction and still function just fine. You asked about vision, and I just want to say, we'll get back to this, but one of the reasons we think that the visual system is so dominant is that it allows us to function and based on perceptions of things at a distance. I mean, the olfactory system does require fairly close range contact. And there's a whole business that we can get into about
that's again because we optimized to not place much in it, right? I mean, if we were elk, presumably I would guess, I mean, I'm making this up again, I would guess that a parent elk can smell its offspring elk at as great a distance as it will spot and be spooked from us, which might be a mile away.
Right. And this is really wild. And I learned this recently from somebody who works on the olfactory systems of species like elk. You know, we think of binocular vision, vision through both eyes, and then you create a coherent picture.
I think I know what you're about to say, and I can't believe it, but go ahead.
The elk and many other animals that are very olfactory driven can sense odor plumes. So think about sort of cones of odor and switch between their different nostrils. And in fact, they can distribute those odor plumes.
So they can geolocate.
They can geolocate. So they can track 3 or 4 young or 3 or 4 hunters simultaneously.
The way
recognize there's 2 over there and 2 over there through odor plumes. They can merge odor plumes. Now you might say that sounds crazy, but we do this all the time. I can talk to you and I can, it's called covert attention. This is the phenomenon of being at the bar and you're talking to somebody, but you're actually checking out somebody else at the bar, or somebody walks in who you really dislike or like. And so you're pretending to have a conversation, but you're really paying attention. Yeah. Covert attention. They can create, or I can bring all my sphere of attention just onto you, wherever you're talking to at the bar. So animals like elk can create and split multiple cones of odor attention. They can also perceive depth with their odor plumes. Now, this is really important, and it makes sense, right? That the concentration of an odor would fall off with distance. We do this with our visual system. Obviously, things on the horizon,
right.
You watch a plane fly overhead, it looks like it's slow. If you're right up next to it, it's going to go blazing past. Or the F1, for instance. I'm always like, why are the cars driving so slow? I thought this was car racing. Then they come by and it's like, and it's incredibly fast. Okay. we'll get back to that because that illustrates or kind of captures the relationship between visual perception and time perception. The same thing at a distance appears to move slowly. The same thing up close appears to move quickly. Even your hand, right? You can even see this at arm's length versus up near your eye if you're sensitive to it, but certainly a car a mile away versus, or my favorite example, go to New York City, get up in a skyscraper, look out the window, and you're looking at the little ants and cars moving, or the people or the ants moving around. It looks like it's moving kind of slowly, right? Then all of a sudden look at something in your room and all of a sudden it's like, whoa, things are moving really fast because they're close. Other animals do this with their odor plumes, which is insane. Insane because it's not our experience. But then again, a pit viper sees in the infrared and can sense your heat emissions in the same way as sensing movement, is sensing vectors of movement, et cetera. Okay, so
let's go back to this question of what was the limit for us to not have that? So again, I'm just going to go back to, given that neither of us were in the design phase, your natural selection, you are the tool of evolution. Presumably there were variants of us that were randomly occurring that had those skills that got outcompeted by the ones that had greater and greater visual acuity. Why wouldn't you have all of the above? Right. Is it literally a running out of real estate inside the cranium? And if so, why not get a bigger cranium? I mean, Neanderthals had bigger cranium. Like, again, it's sort of a question that's unanswerable, but I find these types of questions fascinating.
Yeah, super interesting. And also the fact that we have these vestigial pheromonal organs, which appears to be the case, or we have an olfactory system that can be used to a greater degree than we do rely on it. I'm a huge fan of the work of a guy named Noam Sobel. He used to be at Berkeley and now he's in Israel. He's done experiments. When I was at Cal at UC Berkeley, I used to see people doing these. He would put gloves and goggles, occluding goggles, and all sorts of stuff to block hearing and touch and vision. And he taught people to follow odor trails of chocolate or other, and to distinguish between different odor trails. So you see these poor souls walking around on their hands and knees on the Berkeley campus. Not the weirdest of things basically on the Berkeley campus, you have to be naked and on fire before anyone would stop. But people can learn this, so you can devote more resources to it. But I think the most straightforward answer is likely that we traded out space in there. We traded out space. And now, of course, I don't know because I wasn't there, but there is something important about that relationship between vision and time perception. At some point in human evolution, whether or not it was through the visual system or whether or not it was through the prefrontal cortical mechanisms, something very special happened for old world primates and us in particular, which is the thing that I really believe sets us apart from all the other animals. The reasons that we are the curators of the earth and not other species is twofold. One, the duration of time in our lifespan in which we can engage neuroplasticity, the ability to deliberately change our neural architecture through learning. And the other one is time perception. At some point, we developed the ability to divorce from memories of the past and experiences in the present, and also anticipate experiences in the future. And I don't know because I'm not in the elk's mind or the mind of a turtle, but everything that we know about their sensory life and perception says that, sure, they have memories. This whole notion of a goldfish not having a memory, that's like the stupidest thing I ever heard. First of all, the experiment's never been done. And second of all, like why would the goldfish has to swim in circles? Who decided it forgot? I think that's a myth. So, but they can remember food is over there. Animals cache food for the winter and go back to those cache sites. Squirrels, incredible memory of location and landmarks and all this stuff. We do that. We have a memory of past. We have perception of present, but we also can think about how past and present relate to anticipation of future events. And that places us in an incredible arena of interaction with the natural world where we can make plans, and we can make plans in very specific ways. And so I believe if I were to hedge a guess, I'd say our ability to be so dependent on vision and the fact that our visual system has this aperture, we can view broad swaths of our visual environment. And when we do that, we carve up time in very broad bins. This is very clear. Think about the plane flying slowly. or we can narrow our visual aperture. I mean, you and I could go outside, find a little ant hill, and we could pay attention to all the micro movements of that and focus on that for a couple of hours. We can narrow our visual aperture. Stress or excitement will narrow our visual aperture. And remember the prefrontal cortex. Different rule sets associate with different internal states that also relate to different modes of visual perception. And at some point in human evolution, some ancient version of ourselves figured out how to see into the future. We obviously can't directly see into the future, but to anticipate the rule sets of events that are still yet to come. And other animals, if they do that, they don't seem to actualize on that ability. I always joke, I had this bulldog for years and he loved chasing rabbits, but he didn't wake up on New Year's Day and say, okay, 50 rabbits this year. And if he did, he never actually succeeded in making a good plan to execute that. So
how could we test that? I mean, it seems like that's probably the case. Is there a way that one could test that experiment?
Yeah.
Or test that hypothesis?
I don't know. What I do know is that there are certain states, including dreams, the liminal state between waking and sleeping, when we are completely devoid of external visual input, right? Our eyes are closed. And space and time, this is also true in certain psychedelic states, space and time become not normal, right? First thing we learn is objects fall down, not up, right? These are our caretakers. When I feel stressed, I don't know that I need to have my diaper changed. I just scream, my diaper gets changed, hopefully, right? Those are the rule sets that we come into the world with, early rule sets. But then at some point, our rule sets become very constrained by our immediate experience, right? And by past experience, like, oh gosh, that teacher is not nice. That babysitter.
Right. This is kind of the whole thesis of the Matrix, right? It's Neo having to unlearn the constraints of the Matrix.
That's right. And then at some point, and I do think it's these experiences of vision that are outside the realm of normal experience, that the prefrontal cortex, not us consciously, but the prefrontal cortex learns, there's the possibility, for instance, of, birds fly, we don't fly, but that, I can throw a stick, but what if I could throw a stick with, I don't know, somebody hung some leather ornaments on that stick and figured out they could throw it a little bit further and a little longer, right? I mean, these are the real world experiments have to be done in the present, of course. And now what I'm saying is obvious.
So you're basically saying the evolution of our species suggests that we were able to do this, and we're not seeing that level of complexity in terms of, I don't want to use planning because then it becomes a tautology, but we don't see the complexity and behavior out of other species that we do in ourselves. And is that basically the best explanation?
Yes. Yeah. I mean, most animals don't. This again relates to this other aspect of ourselves, which is neuroplasticity. There's some self-knowledge that we have.
I mean, this is a bit of consciousness, right?
Right. I mean, we're getting a little bit into the abstract, and we're certainly not getting into the realm of laboratory experimentation and having proved any of this. But if I were to put it simply, I think the evolution of the visual system allowed us to think in different time domains. I think things like dreaming and liminal states give us access to visual experiences that are impossible in regular conscious perceptual states. Impossible, right? I mean, I had a dream the other day where I was in a taxi and then all of a sudden I was someplace else. I mean, this is not real, right? But the brain can learn things in those states. I mean, it can learn about new rule sets, new possibilities of rule sets.
Can that be harnessed, you think? So let's just assume I'll give it this is not a great example. It's just the first one that comes to my mind. You go back to, nobody's run a 4-minute mile. Nobody's broken the 4-minute mile. And if Roger Bannister had dream after dream of breaking the 4-minute mile, do we have reason to believe that that would have impacted his physiology and belief system in the way that it did when he actually broke the 4-minute mile, and all of a sudden breaking the 4-minute mile became a standard occurrence? In other words, the rule set got broken in the real world, and that clearly demonstrated a path to progress. Do we have evidence that had that rule set been broken in a dream state, it could have had a similar effect for the first individual?
The best evidence I have is the incredible work of my colleague at Stanford, Aaliyah Crum. I'd love to put you guys in touch and just be a fly on the wall for that conversation. That's what's great about podcasting. We can all be flies on the wall for it. She's worked on these mindset effects or belief effects. These are different than placebo effects. And the short answer is yes. There are a million examples, so I'll give my 3 favorite examples. You give somebody a milkshake, you tell them it's a low-calorie milkshake. You measure things like their insulin, their glucose response, levels of satiety, levels of ghrelin, et cetera. You give another group a milkshake, you tell them it's a high-calorie shake. You take all the same measures.
You'll see different responses.
Vastly different responses. You give hotel workers a little tutorial on the fact that, cleaning hotel rooms is boring, but it burns calories and can lower blood pressure, help you lose weight. They lose on average between 8 and 11 pounds in the following 3 or 4 weeks. Okay. You don't say anything to hotel workers about all the benefits of their work and the exercise that it includes. You just tell them that it involves a lot of movement, et cetera, et cetera. No consequence. There's clearly a mindset effect. And my favorite example would be the one related to stress, which is you tell people all the negative impacts of stress on memory and well-being and immune system, or you tell people also true data on the performance enhancing effects of stress, sharpening of memory capacity, reaction time reduced, which is also true. And you see exactly what people believe and what they're told and what they believe. You can't lie to yourself, but what you believe about a given practice strongly regulates the physiology. Now, this is interesting to me in terms of the 4-minute mile or other things. Like you tell people that the burn of lactate, the maybe even the lack of sleep that they had the night before reflects a training adaptation as opposed to overreaching and overtraining. You're going to see very different outcomes.
Yeah.
In fact, Allie's been cueing me to the idea that a lot of this sleep tracking stuff that you tell people you didn't have a good night's sleep, they feel like shit the next day. You tell them they had a great night's sleep, independent of their sleep physiology. And listen, I am as much a proponent of sleep as the core of mental and physical performance as Matt or anyone else, you included. But let's be honest, what you believe about what you've been told has an immense impact on your physiology. And I use this to explain some of the battles around nutrition where you hear like these dweebs over here are saying this online and these dweebs and goons over here. And it's kind of silly after a while. Clearly there's a distribution where facts rule and physiology rules, the laws of thermodynamics are intact, but then these belief effects can account for anywhere from, according to her, anywhere from about 8 to 20% of the effects of anything like a food or a behavior. She actually set out in her thesis at Harvard to study the effects of exercise, and her advisor said to her, I think all the effects of exercise are placebo. And it was kind of it was a prompt to go actually look at that. And she thought, well, that's crazy. Allie's a former D1 athlete. She's also a trained clinical psychologist, runs a lab at Stanford. She's one of these superhumans. But she said, well, that's crazy. No, exercise changes blood pressure by way of a number of different physiological mechanisms. But she went and tested this idea that it's all placebo. In fact, that there's a lot that is placebo. So mindset effects are real in terms of physiology. Now, does that allow people to break mental barriers? Well, for certain things like engineering, like sending rockets up to Mars, clearly there's an engineering feat that has to be that has to adapt to the physical world. There's nothing obvious about that. I can't just will it into existence. But in terms of what the limits are on human performance and what the limits are in terms of creative endeavors, well, as far as we know, that's infinite. Our good friend Rick Rubin, right, has a book on creativity coming out, and I don't want to talk about it because there's no way I could capture Rick's brilliance there. But he and I have had a lot of discussions about this, and it's clear that creativity is combining of existing rule sets, but also coming up with completely novel rule sets. And this is something that for the philosophically oriented or for the neuroscience oriented or psychologically oriented is a fun space. I mean, when was the last time any of us took a walk and thought, how do I completely fracture my notions of the rules in a given domain and think about truly new ones? It's hard to do. But once you set for lack of a better word, the intention around that, I do believe that when you enter sleep states, that the brain tries to solve the most important problems that are happening in your daily life.
I think I talked about this on a podcast with Matt Walker a long time ago. I have, and I'm sure everybody can relate to this. There's something really beautiful about singular focus and purpose in life. And for me, some of the fondest memories would be in, college and medical school where, life was remarkably simple. You had no responsibility whatsoever. And when I was an undergrad, mean, I don't possess the vocabulary to describe how much I loved mathematics.
There probably isn't a vocabulary for it.
Well, I'm sure somebody could, but my vocabulary is not advanced enough to put into words the affection and the joy that mathematics brought me. And the example I gave was I would dream about math problems. And I remember in the real world, I was trying to solve a problem. It was a dumb problem that I had made up to solve, which was I wanted to integrate the volume of a face. And I got stuck on the chin because there's a dimple on this chin that I was trying to integrate. And I went to bed and I actually dreamt the solution. I dreamt the function which needed to be rotated around a z-axis to come up with the integral. And I woke up, got out of bed, and solved this problem. And I'm thinking to myself, like, that just doesn't happen anymore. And it probably doesn't happen anymore because I'm so distracted. There are too many things I'm trying to do, and I lack that real sense of purpose. And I don't know. I don't know if I'm sure you've experienced this in your own life.
Oh yeah. I mean, I think that one way to describe it in the context of the neural architectures that we've been talking about is you have all the necessary rule sets to complete all the demands of your daily life, from parenting to podcasting to running your clinical practice and on and on. And so you know how to toggle between those. You know not to apply one rule set in the wrong context, and you just go. And there's an energetic cost to that. When we are singularly focused on one context, even if it's one conceptual context, you still have the same amount of total neural architecture.
Right. Now it's just concentrated.
Just devoted to that. I mean, I still have images burned in my brain of neural tissue that I was viewing down the microscope. I can close my eyes and still see it. Now, I don't have I'm not, photographic memory. I don't have a photographic memory. I used to have an audiographic memory where I could turn on a recorder in my head and then I could listen back to those conversations in the evening. A very dangerous thing to have, actually, and to get into an argument with me at that time was no good. But because I could remember what you said, I lost that ability. And I think I lost that ability not because I truly lost it, but I'm thinking about other things now. Now, that was kind of a useless ability, frankly.
I don't know. That sounds like a more useful ability than being able to integrate faces.
Well, it helped me learn certain things, but I think ultimately being fairly narrow context and being able to access these broader rule sets and come up with new rule sets is incredibly powerful. Now, there are certain states of body and mind that favor this creativity process, if we can call it that. And you said it precisely, which is, and this is not a woo thing, I truly believe that even though our ability to be gritty and to survive allows us to access a number of important rule sets, we know based on the relationship between stress and survival that those rule sets and the prefrontal cortex, that those rule sets, are constrained, right? So I put you into a dangerous situation where you need to protect your family. You're going to figure it out. I trust you. I know that. I know you're going to work it out. But I also believe that there is a state of love that is associated with access to a much broader rule set and creative rule set. And how do I know this? Is because it underlies our evolution as a species. The number of different things that you can do to access survival if you're taking care of your family is immense, but the number of different adaptations that you can come up with in order to raise your children to be as happy and healthy as they can be out of love is absolutely infinite. Why? Because it really is, there's no other option. You're not fearing death. What you're doing is you're trying to access this landscape of you want them to be as great as they can be. You don't know how great they can be. That's the infinite rule set. And so the not having constraints on what the outcome is really the way to access expanded rule sets. Now, this is getting a little bit circular. I have to be careful and check my thinking. I'm sure the philosophers out there are going to, nitpick this, and I hope they would. But in discussions with Rick about creativity and in discussions with you and other folks, it's very clear that that accessing these brain centers that have full understanding of internal state and then full understanding of past, present, and future, that is absolutely the best state to be in order to access expanded rule sets and ever expanding rule sets. Whereas anytime I'm accessing knowledge about internal state, but it's constrained by outcome, I need this not to happen, you've already shut down a number of rule sets. right? So anytime, and this is why I think in dreaming, we aren't constraining our rule sets. We all wish we could, but we're not constraining our rule sets. It could be a nightmare. It could be the best fantasy we've ever had. You can fly, all these things. The rule sets are infinite, but constrained by experience. We're not aware yet that we can dream about things in a way that does not reflect what we've already experienced. We might be able to. We don't know enough about sleep and dreaming yet. The idea here is that placing one's mind and body into states of, and again, I'm sounding squishy here, but love, or we could also think anything that doesn't include a but not that is an expanded rule set, right? So I'm not going to do this podcast spinning around in my chair on my head, but the moment I decide what's appropriate and inappropriate behavior, I've now started to constrain the rule sets. Okay, so we can go around this circle as much as we want or as little as we want. But I think that once people start to understand what places their body and mind into the most relaxed and quote unquote open state for accessing new rule sets, the more quickly we can solve problems. That's absolutely clear. And we know this from the laboratory. If I give you cognitive tasks and I just ramp up your level of autonomic arousal, and we do this in my lab, or there are any number of different ways to do this, you can function up to a point, but it's mainly dependent on how well you have performed that thing in the past. I give you something novel, I switch the contingency, I give you the kind of a more advanced Stroop type task, everybody cliffs. I don't care if you're a SEAL Team 6 guy. I don't care if you've run 3 countries. I don't care if you've parented 12 kids on your own. Your rule sets are constrained. And so I throw something novel at you under conditions of even mild stress, and you break down. I throw something novel at you under conditions of relaxation, and you can pull from what might even seem like ridiculous rule sets, and you can start solving problems. And humans do this exceptionally well. And so I think that the more we can narrow context, as you said, medical school or math or parenting, whatever it is, the more that we can narrow context, even if in the moment, but the more that we can be in a relaxed state, and ideally a state of something of wanting, not avoiding, the more rule sets we can access. And I think that's where creative solutions come from. I mean, I have to imagine that even though he's a brilliant engineer, that Elon wasn't thinking about going to Mars because he hated Earth. He's thinking about it because he loves the idea of going to Mars. Now, I'm not his psychologist, but I think every major advancement in human evolution has largely from a desire for something as opposed to an avoidance of something else.
Boy, I'd have to think about that. Yeah, that's interesting, right? I mean, although let's think, for example, so think of some of the amazing advances in cryptography and nuclear physics in World War II. I mean, you could argue a lot of that was fear-based, right?
Yeah, but yes, I completely agree. But I would argue that the people doing that work, if you were to really sit them down and
they just loved that they were solving a problem.
They loved it. Right? We think of we got Feynman all around us here, and he played a prominent role in my home and my childhood as well. And I mean, the love of what he did that came through. Sure, he was working on the bomb, right? But he was also enjoying picking locks and laying out all the secrets on the floor of the offices because he loved the playfulness of it, right? I mean, it was love, delight. I think maybe love is too much of a loaded word because it sounds like, oh, love, Andrew's from Northern California, like he's spent too much time at Esalen, whatever. That's not actually my hangout place, even though it's beautiful. That's not really what I'm about. But I think delight is what captures this like fascination, curiosity, and thrill of something that we see or experience and want more of. I think delight is probably the better word for it. And I think, I'm sure you can get a lot done out of fear and the need to adapt. You get a hell of a lot more done out of a genuine desire because you just want more of that thing. So I would argue that cryptographers were in bliss. Now, they didn't want to get blown up. And they'd love to save people, but there can be multiple purposes behind doing something.
So let's kind of go back because I feel like there's so much that I know a little bit about you, but I don't think I know the whole story. So you grew up in NorCal or SoCal?
Yeah, so I was born at Stanford Hospital. The joke I have is I was born at Stanford. I kind of hung around skateboarding on campus in my youth. Then I was trained at Stanford in part, and then been faculty member. So I'll probably die at Stanford, but hopefully a long time from now. So I was born in Palo Alto. My dad's from South America. He's Argentine. Dark hair, dark eyes, speaks Spanish and English. And he came to the U.S. on a naval scholarship. He was an experimental physicist at UPenn, met my mother in New York, they moved to California, had my sister, who's 3 years older than I am, and me in the early and mid 70s. My dad took a job at Xerox PARC, early days of the personal computer, the so-called graphical user interface and things like that. And my mother was a stay-at-home mom, was a teacher. And
that was in Menlo Park?
It was in Palo Alto.
Alto.
I lived right over the fence from Gunn High School, Gunn, the high school that's infamous for having the huge number of youth suicides. Yeah. Unfortunately, that's adjusted. A lot of kids of Stanford professors. It's not the Palo Alto High School on the other end of town. So our end of town tended to be a bit more middle and upper middle class. Palo Alto at that time even had Midtown, which there were some families that were definitely at or below the poverty line, believe it or not. Nowadays, it's, Palo Alto is all pretty upper class. So yeah, I had
including East Palo Alto?
East Palo Alto still struggles.
Yeah.
East Palo Alto still struggles. Great people there, but really struggles. So growing up from birth until about age 12 or 13, it was soccer, swim team, tons of kids on my street hanging out. There were all these boys my age, they had all had older sisters my sister's age, pretty magical childhood. And my dad transitioned into theoretical physics, and he was involved in the early days of chaos theory. So we spent a lot of our youth in Aspen in the summers, not because we were part of the wealthy Aspen set, but there's the Aspen Center for Physics. So I grew up running around hearing about, Peter Kaus and Feynman and Mary Gell-Mann. Those were regular characters in my life, and met, those folks, and they were around. A lot of stories about academics. So I was kind of exposed to the academic world. And then, and frankly, it was a pretty cool childhood. We did a sabbatical in Europe, and I got real close with my sister because of the sabbatical. Still really close with my sister. She's a therapist, and an excellent one. Not my therapist, but an excellent therapist. And it was pretty like normal childhood. Wasn't a great athlete, wasn't a great student, but I was always super curious about biology and animals, like absolutely obsessed. My mom used to drop me off at Monet's Pet Shop on California Avenue. For those that don't,
still live on California Avenue.
Oh, did you? Yeah, it was directly across from Draper's Music, which is where the Grateful Dead got their start. And those guys used to hang out there because they were from Menlo Park. The Edge, there was a club, the Edge. You wouldn't find that in Palo Alto now. So it was a pretty healthy upbringing. We didn't have any issues around like alcohol or drugs in our home. It was 2-parent home, dinner together every night. But there were some things looming under the surface. And so everything took a hard turn when I was about 12, 13. My parents divorced, and unfortunately they didn't read the rule book, or if they did, they broke every rule in the rule book. And it was a very high conflict situation. So my dad moved out. I lived with my mom. My sister went off to college. And at the time I had gotten into skateboarding. I wasn't so much playing soccer and doing other things. And I fell really deeply into the community of skateboarding, which at that time was really underground. It wasn't like it is now. I started skateboarding is a unique sport because you have interactions with kids of a lot of different ages. So you're hanging out with like 30-year-old guys, 20-year-old guys, kids your own age. And a good friend of mine named Paul Zawanich was really good at skateboarding, and he started picking up sponsors and turned pro while we were in high school. And we started going up to San Francisco and hanging out at the...
And you were still in the peninsula?
Yeah, I was at 13, 14 years old at the kind of famed what's called Embarcadero or EMB crowd. It's early for skateboarding. This is a huge deal. It's kind of the golden era of street skateboarding. And there I got exposed to a lot. I got exposed to drugs, alcohol, fights. I got exposed to a lot of kids that just didn't go to school. Just didn't go. There were a bunch of, a lot of untoward elements. Also a lot of amazing skateboarding, just amazing. Got to see, I can throw out names, but the young Danny Way would come through town, or Rob Dyrdek would come through town. And, these names will be familiar people, maybe DC Shoes, those guys were involved in that. So I got to see all this stuff. In full disclosure, I wasn't a very good skateboarder. I was okay, but I kept getting hurt. I just didn't have the athleticism. I hit puberty late. I had a long arc on my puberty. This is something I someday want to understand, which is I think there's a relationship between how long puberty lasts and longevity. I think it makes sense. Anyway, I hit puberty around 14, but I didn't acquire the secondary sex characteristics. I didn't grow. My musculature didn't come in. My physicality didn't develop until pretty late. Didn't grow a beard until college. Couldn't grow. It was weird, but by the other marks of puberty, let's just say I hit puberty. Okay. So I had all this upset about my home life. Frankly, it was pretty bad. My mom was struggling a lot. My dad was trying to be in the picture, but there was a lot of conflict between us. In any case, what happened was something about my behavior cued the school system, probably the fact that I wasn't going to school much anymore. I got taken away. I got put into a residential treatment program up on the peninsula. This was not for drug use, alcohol use, or hurting anyone or myself. This was mainly for truancy, and they were really concerned about me. Okay.
Did they require the permission of your parents to do that?
Yeah. So I remember one day just getting called into the office, and they were talking to me, asking me questions about my home life, and I, pretty quickly caught on to the fact that something was going to happen, and let's just say I did everything I could to resist getting taken away, but they took me away and put me under lock and key there. And I remember,
what grade?
I think I was in the 9th grade. So I was in the 9th grade, and I was really angry, really upset. Yeah, it's interesting. I don't have a ton of emotion around it anymore, but I do feel like it was a terrible situation for me to be in, because like my home life was so bad at that point.
Your sister was already in college?
My sister was gone. I think the way to capture my home life at that point was there was just no one there. There was no one there, and what was there was really scary.
And what was your mom doing? Was she working at this point to make up for your dad being gone?
She took a job. She was working. But to be honest, and look, I love my mom, and I love my dad, but they just were so focused on their own stuff. Like, I think there was so much anger and resentment between them. And I just basically was kind of running my own life. I was doing whatever I wanted, which is terrible for a 14-year-old. Like, boundaries are great, rules are great. And I had this community of young guys that was an amazing community, learning from some of the older ones, learning some not healthy behaviors, learning some healthy behaviors too. But when I got put away, it felt to me super unfair. But I met the counselors there were amazing. And I also was very lucky that drugs and alcohol were never really my thing. So a lot of kids there were dealing with drug and alcohol issues. I remember when I got there, they said, listen, there are these younger kids here, and they're crazy. They're like miswired. And then there are adults over in that other building, and they're crazy. But you guys here, you're not crazy. And I remember thinking, they have to be saying that to the people in the other buildings. So there was this moment where I'm like, is there something genuinely wrong with me? Like, I didn't do anything except I was not taking good care of myself.
And did you still leave the facility each day to go to school, or was school within there?
Locked up in a room. My roommate turned out to be a really good guy. He was a huge guy. He looked like Richard Ramirez, the Night Stalker. And I was remembering, like, I can't sleep. They're coming in doing bed checks like 3 times a night. They're frisking us. They're doing cavity searches for, did we bring in weapons? Did we bring in drugs? You're doing group therapy with all these people. Some of them are talking about terrible molestation experiences, which fortunately I didn't have, drug things. And I'm just thinking, like, why am I here? Like, I had no idea why I was there. And I remember at the time I had picked up one skateboard sponsor, which was Spitfire Wheels and Thunder Trucks. They put me on out of sympathy. Mm-hmm. And the team manager, I'm actually friends with him still. His name is Steve Ruge. He's not a pot smoker now, but back then he was, which will explain the voice I'll use in a moment. But I remember you literally got one phone call. So I wasn't going to call my parents. So I called Steve, and I was like, hey, Steve, I'm locked up here. Like, I'm in the peninsula. I'm in Belmont. I don't know what to do. And he goes, man, he's like, you're the most normal guy I know. I can't help you. And I thought, I'm really stuck. Like, I'm genuinely stuck. Like, what am I going to do? And I remember thinking, like, I just didn't know where to go. So what happened was I eventually worked the program they gave me. Someone there said, listen, just like play the game. But eventually I realized I was like, they're asking questions that I actually want the answers to. Like, what's going on in my head? Why am I just letting my whole life go? What's going on at home? And it turns out that it was just it's a very, I'll summarize by saying what I was dealing with, I can now in retrospect, it was a super traumatic, daily traumatic environment if I was at home, or it was just like pure neglect, right? I mean, just pure neglect. I mean, prior to that year, I'd gone off to skate camp. There was a skate camp in Visalia, and all the other kids like went there with their bags and their parents to send them out. And I just like went We just like hung out. We would just get in cars and go. We went to Reno for a week to skate in the nationals. I sucked, but I went anyway. And we were just there, a bunch of kids. We were just parentless kids. So I was part of this huge group of parentless kids. It's just Gun High School, there's a spotlight on me. Whereas I think had I been in an inner city school or something, you probably would have gone under the radar. And it gave me great sensitivity to the fact that, like, growing up, like, the word gets thrown around a lot, I think these days in the incorrect ways, but it's like, I was very lucky. You could even call it privilege, but very lucky to have that there was a spotlight on me. It was high signal to noise, right? This kid's really crazy. I also was getting into a lot of fights. So I was getting into street fights and that whole mess. And so I eventually got out, and the agreement was I would switch high schools.
How long were you in this place?
I don't know. Is it a month or more, which was plenty of time, frankly. You're not controlling your food, your sleep. It's all on their plan. Good kids were there. We lost a couple of kids. A couple of kids killed themselves while we were there. It was
while there.
How? You could get stuff in.
Wow.
There was all sorts of networks in there, and it wasn't jail, but it wasn't far off. It sucked. And I always tell I don't do a lot of youth mentoring or anything, but I always listen. The moment that lock goes down or you're in handcuffs, it's like your control over everything just goes away. Like, it's just truly something to avoid. So one of the agreements on getting out was I'd switch high schools and I'd start therapy. They wanted me in a new high school.
Now, you went to a great high school.
Yeah.
Was the idea that they just needed to get you a new peer group?
They weren't so concerned with my peer group. So that the idea was going to be that I'd live with my dad. And I was actually excited to do that at the time. It was something I'd requested. So I ended up switching to Palo Alto High School, so-called Pally High, just across from Stanford campus. And at the time I had a girlfriend that went there, who I met because I worked at the local skateboard shop, Palo Alto Toy and Sport World, skateboard shop in the back. And she came in there. We started.
Wait, Palo Alto Toy and Sport was still there when I was there.
Yeah, it just closed recently. It was one of the oldest businesses in Palo Alto. Yeah. I worked in the skateboard shop in the back, and in the shoe department.
Used to buy my goggles there.
Yeah. Oh yeah. Yeah. A lot of swim stuff. Yeah. I have to say, one thing that I had kind of baked into me is my enthusiasm for animals, and I liked work. I always had summer jobs. I had paper routes, and I worked at the skate shop and all that kind of thing. But I moved to Palo Alto High School. I was supposed to live with my dad. And then, and this, I have to be respectful of certain elements of privacy, but for certain reasons, it was decided that I wouldn't live with my dad. And at that point, it was just like gasoline on fire. I was like, okay, I can't live with my mom. I can't go to the high school.
By your determination or by theirs?
It was not my decision to not live with my dad. So I was like, oh my God. So now all of a sudden it's like gasoline on fire. And of course I'm hitting puberty too. So now meanwhile, no attention to school, no interest in biology anymore. I'm just like skateboarding and like just being a punk, right? But also having a lot of fun and loving my friends, and my girlfriend at the time was really sweet. And so I ended up going to Palo Alto High for about 3 weeks and then just stopped going. I was just, so it was like everything was just getting worse, worse, worse. Now, the thing that really saved me was this therapy thing. So I was placed into therapy. I had to go once or twice a week. I don't recall. But that therapist, who was trained in mostly psychoanalysis, but in some other dimensions too, was like the first person that really like paid attention. I was like, oh shit, and it's interesting because I do have the emotion. I do have to choke back a little bit here because, my parents love me. I love them, but it's a crazy thing to have somebody say, listen, like to give you the confidence, like, we're going to figure this out. There's something very powerful about that. It wasn't like, everything will be okay. It was like, we're going to figure this out. And that to me was like an amazing dialogue to be in. So it was like, okay, let's parse your situation, but even more so, let's just focus on what you want to do, what you want to create, what's important to you. So I started working with this person, and I'm not shy to say I've continued to work with that person 1 to 3 times a week until now.
Mm.
And so, you think about sort of mentors, and very lucky.
30 years later.
This is more than 30 years later. Yeah. So more than 30 years later. And I confess at times, I had to request some budget help to do this when I was a graduate student. It was really hard to do. I eventually had insurance that helped. I'm in a position to still do it, but to just be able to understand my own thinking, to be able to separate what was happening around me from what I wanted for myself. And look, I had a number of huge mistakes along the way. It did not allow me to avoid mistakes. And, I eventually, what happened was I got a different girlfriend. I stopped skateboarding. I got hurt really badly. And I started getting involved in fitness. There was a football coach at our school, Bob Peters.
And were you now still back at Palo Alto?
I went back to gun. There was an agreement, and it was interesting because my hair used to be dyed black. I let my hair grow out natural. I started wearing like not skateboard clothes. I sort of kind of decided to just kind of be a little less outrageous. But I started Thai boxing, which was great. There was I got involved in martial arts a little bit. Wasn't very good at it, but I was okay. Started lifting weights. My body reacted like crazy to that. I wasn't on any hormone support. It was just the youth thing. I just kind of responded really well to that. I started running. I ran cross country, started getting really into running and lifting weights. And I still wasn't very focused on school, but I was doing a little bit better. And the girlfriend at the time was a year older, and she had a really good work ethic. And I started, I would run to her house on Sundays and wash her car. I just started doing a lot of physical labor, and I figured I'd go into the fire service. I was like, I could do that. And I started taking fire science classes at Mission College. Loved the guys there. It was like workout.
This is while you're still in high school.
While I was still in high school. And I will say that at that young age, I made the mistake of, I started dabbling in some drugs. No hard drugs, but psychedelics, which I think psychedelics have their place in the therapeutic context when people are older. But while the brain is still developing, I don't think it's a good idea. So started doing that. I don't know how much to disclose or not out of respect for other people, but, I had a girlfriend early, there was a pregnancy, there was a number of things where, my life still wasn't bolted down. And that was causing problems for me. And, but she was very loving and was great. And what happened was she went off to college. She went to UC Santa Barbara. And so my senior year, I was going down to visit her. She was already there, and sleeping in the parking lot outside her dorm and hanging out with people there. And so she was like my family. I basically mapped everything onto her. And eventually what happened was I applied to Santa Barbara because I'll be damned if she was going to be far away from me. And somehow, I do not know how, I got in. I think I barely broke 1,000 on the SAT, but I don't remember studying. And let's just say the night before, I was not putting myself in the most focused preparatory state. Somehow broke 1,000.
You didn't do the optimized sleep, nutrition, exercise, stress routine to take the test?
No. And if I reveal what I did to take the test, I think it might send the wrong message.
Yeah.
But anyway, so I won't. But I got into UC Santa Barbara, and I went there to be with her. And let's just say 2 quarters into it, I had more fights than I did time in class. And by the end of the year, I was basically flunking out.
Why do you think that was?
I think I was just had so much fire and so much anger. I think I was just, it's interesting. I've never been angry at people. Like I wasn't angry at anyone in particular. I just had so much like fire inside.
I mean, at the risk of stating the obvious,
Yeah.
It sounds like you were very angry at your parents, and you had good reason to be.
Yeah, I was very angry with them.
And I assume your therapist came to a similar conclusion and helped you see that. What were you able to do to try to reconcile or come to peace with that anger at your parents throughout the 3 or 4 years in high school, where you were presumably getting back enough on track to at least be in a position to apply to college?
Yeah. And credit to my high school girlfriend, because basically there was no organization in my life except the organization that I wanted her to see I was capable of.
And her parents must have loved you.
They hated me.
Oh, really?
They hated
So they tolerated
me. Her dad.
It's not like you were an adopted son to
her
them.
Her dad recorded our conversation. He was like, "This guy's a punk. Why are you with him?" He was right. I mean, he was completely right. So these people know who they are. He was completely right. He recorded our conversations. He was like, "This guy is complete disaster." She had a tough home life, really tough home life. And so I moved in kind of a protective role too. But, you know, she was a hard worker and her dad was an extremely hard worker. And so I had a lot to prove. And I also was learning that, you know, especially with running and lifting weights and the stuff in the fire service, there was a direct relationship between input and output.
Yeah.
Whereas in skateboarding, I always felt like it was like 10 units of input and I'd just get hurt. I just wasn't a natural athlete for it. So, you know, there was some work done with my parents where you do these one-on-one things in the therapist's office and I would express my anger or whatever it was. But I don't actually remember being so furious as much as just feeling like you people don't know what you're doing. Like you have no idea what you're doing. It was clear, like the way they just didn't get it. I just thought, and now, you know.
Can we tell a funny story about this is every time we have a meal, I learn something about you that is so remarkable. I can't believe it. And I think my favorite of the week is you're at some skateboarding thing and like there's no one there to take you home and you end up getting a ride home with Tony Hawk's dad. They fly you home.
Yeah. So this is wild.
Or they bring you back home to San Diego.
I'm 14 years old. I go to the Linda Vista Boys Club. I compete in this skateboarding contest. I do terribly. And then everyone heads off in their cars and like off to their places or with their girlfriends or their parents. And I'm just there.
Yeah, you're just twiddling your thumbs.
Right. With this kid, Billy Waldman, who people in the skateboarding, that the people refer to him as the demon child. And Frank Hawk, who's Tony Hawk's dad, who ran the National Skateboard Association, comes up to me. He's like, where are you going? And I was like, well, I'm from Northern California. I was going to take the bus to Lancaster. There's this guy that I know in Lancaster. And he's like, no. He's like, you're coming with me. So he and his wife, Nancy Hawk, took me to their home. Tony had moved out. I slept in Tony's room that night. It was like, to say it was filled with trophies is an understatement. There's no space for anything except the bed because there are so many trophies. So like, this is cool. In Tony Hawk's room, we went to dinner and
that's like, that would be like me somehow winding my way into Ayrton Senna's room after he's, you know, I mean, it's ridiculous.
It's ridiculous.
Yeah.
And so they eventually flew me home. I think Frank talked to my mom and was like, hey, listen, you know, this kid needs some guardrails, you know, because skateboarding has a lot of truants and a lot of wildness, and always did. It's part of its appeal to many, you know, no parents. You don't need parents around a skateboard, right? You don't need your pre-workout drink. You need Slurpee, you know, like you know, I mean, it was still like, or beer, right? I mean, it's beer and cigarettes. I mean, you know, the 16-year-old me or 15-year-old me on skateboard, like a pack of cigarettes. I was like so that was me then. I don't recommend that. But so what ended up happening was the next day he took me to Tony's house in Fallbrook, got to meet Tony and Ray Underhill and a bunch of other guys and see the ramps and pump around on the ramps a little bit, and then flew home. And that was an amazing experience. And then years later on Instagram, I sent a direct message to Tony and said, hey, listen, I know you get a ton of messages, but you know, your dad really took me in and his mom had passed away recently. And I said, I'm really sorry. My condolences. I said, and if you don't believe that my story is true, how's this? Your parents used to drink black coffee after dinner. And he wrote back, I was like, no way. Like nobody would know that. Right. Yeah. But I remember thinking it's 8:30 at night. We just finished dinner and they ordered black coffee in the restaurant. So that was pretty cool. And yeah, a number of people, you know, swooped in and tried to help me along the way. I mean, I also had amazing experiences skateboarding. Be a 14-year-old kid at the Reno Nationals, running around the casinos with your friends and seeing these amazing skateboarding. And yeah, you're also seeing like rampant amounts of drug use and rampant amounts of like odd types of, let's just call it, wasn't traditional dating and relationships for high school students. And you're like, this was the early mid 90s or early 90s. And it was fun to be free and wild, but I felt like I was always the guy at the end because I wasn't very good at skateboarding and I didn't have a home and I didn't have any structure. I was the guy that like didn't know where to go. It was like, I didn't know where to go. And to this day, even if I'm at a scientific meeting and everyone clears out at the end, I get totally depressed. I'm like, I feel like I've got nowhere to go. I've owned homes. I had a dog. And there were times when I was like, wow, like it's, you know, like knock on the walls, like there's really something here. So yeah, I was angry with my parents. And I think I was also just kind of like flabbergasted. Like, you know, now, you know, I having spent time with kids and friends who have kids, you know, 14 is pretty young. You know, and I was involved in all sorts of things at 14 that like, I would never subject a 14-year-old to ever. Like you want to preserve that innocence of youth as much as possible. And at the same time, I mean, it forced me to grow up, So I think the fighting, and I think the hard work, and the fact that I thought about making a living really early on and all of that, feeling like I had to grow up quickly, and
So you're in your first semester at
yeah,
UCSB, and you're getting into fights with townies, with college kids.
just people. I was never somebody who provoked fights or initiated them, but I was just, somehow it was just finding me, and I was not a big drinker, but that town, there's a lot of alcohol intake. So what happened was, at that summer between my freshman and sophomore year of college, there was a house that everyone hung out at, and I decided to stay there for the summer. Wouldn't go home. What would I do at home? The girlfriend and I had split up. We were kind of having our issues, and I was living in the town of Isla Vista with my pet ferret, and I was squatting in a house. I was like, why would I pay? Like, skateboarding, you learn how to just kind of squat in places. So delivering bagels for the bagel cafe, and we show up at a friend's house, and a bunch of guys were stealing some stuff from the house. It was clear they were loading up their cars. So got into this fight with a bunch of guys, and the people I had shown up there with all scrambled. They all just took off. And so this fight started getting ratcheted up into weapons, and and people hitting each other with skateboards, and so knives coming out and the whole thing. The police show up. In the end, I was let go because we were, quote unquote, protecting our property. And I remember one of the police officers congratulated me. He was like, good job or something. I just remember feeling like, this picture sucks. Like, here I am, I'm now 19 years old, no future in skateboarding. I barely went to class, getting in fights. I'd been thrown out of the dormitory for something stupid related to that. My girlfriend and I are split up. I work at the bagel cafe. I was like, this is it.
And why at this point did you think about, hey, I still have this whole thing as being a firefighter potentially? Was that?
I think at that point I was just like, I don't really know what to do. I just remember walking back to the place where I was staying and just thinking, like, I'm a total screw up. Like, I'm officially a screw up now. I don't care where I was born. I don't care what my parents did. I am officially a screw up. Like, it doesn't matter. Nothing else mattered. And I actually wrote a letter. I still have the letter. I wrote a letter. It was the summer of '94, to my mom, saying all the things that I kind of felt about the past and what I'm going to do going forward. And at that point, I really did make a hard left turn. I moved home. I took a leave of absence. I didn't quit UC Santa Barbara. I took a leave of absence, moved home, went to Foothill College. My sister was home from abroad after college. We lived at our house. Our mom was there, and this other girl, we rented a room to. But I went to Foothill College and just was like, I'd listen to myself. I'd say the one thing I know how to do is memorize information. So I just started focusing on coursework and working out. And from that point on, except for one course in college, I was a straight A student the whole way through. So what happened was, after a quarter there and a summer, I went back to Santa Barbara. I lived in a studio apartment by myself. I got back together with a girlfriend.
And how did you fund this? Did you just take out loans to do all this?
Yeah. So my education was supported in part. There was some money that fortunately, and here I was very blessed. My dad obviously helped. Not obviously, but my dad helped. That was great. I remember I didn't want to go back to Santa Barbara. I wanted to go to Whitman College in Walla Walla, Washington. I want to be a journalist or do something related to writing. He said, no way. I'm not going to pay for some, sorry to people in the Whitman. He was like, no way, no fluff education, like liberal arts school. You're going to go back there where there's some sciences. You're going to do something. Anyway, that was my house. And I went back, and I just was a machine. It was like Henry Rollins style, just like workout. I listened to Rancid, listened to Bob Dylan, listened to classical music on loop, drank coffee, worked out, ran, studied, worked out, ran, studied. And my goal was to be on the far end of the curve. They used to publish the curve or every class outside. And I just became a straight A student. Now, the twist in this is eventually I started working in a laboratory. I took a class from a guy named Harry Carlisle, who was teaching about mental health and neuroscience and physiology, brown fat. He had worked a lot in brown fat thermogenesis. I started working in his laboratory on brown adipose tissue. So and dopamine antagonists and clozapine neuroleptics and effects on temperature. I was obsessed with physiology and temperature. Meanwhile, I was getting really interested in fitness and supplementation. And I tried to run cross country for Santa Barbara, but you had to run a sub 10 2 mile. That was way too fast.
Wait, a sub 10.
2 mile.
Oh, 2 miles.
That's to walk on. And there's no way these guys were built like whippets. And at that point I'm 6'1". At that point I was about 185, 200 pounds. There's no way I was going to do it. So I was really into fitness still, and I was studying.
How fast do you run 2 miles today?
I don't know, but my fastest mile ever was in high school. I ran a 4:57 first mile in a 3 mile race, and then bonked and had to walk off the race. So basically I failed the race, but that's what it was pure adrenaline. It wasn't training capacity. So now I'm not that fast a runner. I run a couple miles. I do a 2 mile run once a week, and I'd be happy with a 12 to 13 minute time. I'd be very happy with that, in fact. So, I started getting really into working in Harry's lab, and he was great. My kind of guy. He smoked cigarettes in the lab. He'd light them with the Bunsen burner and smoke in the fume hood. We drink coffee. We were injecting rats with MDMA. We were studying the temperature regulating effects of MDMA, and we were studying amphetamines, and I was learning so much neuroscience, and I was like a kid in a candy shop. I was like, this is amazing. Now, there wasn't any neuroscience at that time. It was called neurochemistry or neurobiology. And I was taking psychology classes also, and the degree was called biopsychology. Now, I was a little late to the train, so I was taking biopsychology courses and psychology courses. And then I met a guy named Ben Reese, who is expert in visual system and visual system development. And I started learning about all these retinal specializations. Then I learned there was a guy on campus named Gerald Jacobs who discovered the evolution of vision and color vision. He's a member of the National Academy. I started hanging out with all of these guys. And so my crowd completely changed to a bunch of neuroscience dorks who were, to me, the coolest guys in the world. And in many ways still are. I think I have immense respect for Ben and for Gerald and all those guys and Harry. And so it was just incredible. And I thought, wow. And I'm learning about all this mental health stuff that I saw when I was locked up, that I saw in my friendship circle, in my family, people who have anxiety, there was schizophrenia. It's neurotransmitters, it's dopamine, it's norepinephrine. It's not just, Freudian theory, even though I respect Freudian theory. So I became a monster of school. And then the girlfriend graduated and we decided to part ways. And
wait, the same one?
Same one.
Did you guys get back together?
We managed to make it about 2 more years. And then for better or for worse, now looking back, I think like, okay, could have it worked out? Probably, maybe not. It's one of those you don't know. But I was on a mission basically to go to graduate school. And so I don't want to break, it would take us 5 hours to go through all this. But at this point, it was like no drinking, no drugs. Once a month, I would go out and really tie one on with friends, like really have a blast. / drinking too much, not a good idea, period. But at the time, that was still in my framework of what I could do. But then over time, I was like, I don't want to do this.
Now you're still with some regularity talking on the phone to this therapist
every week.
And I want to kind of go back to this pivotal moment, but was it that fight that you had where the cops came? Was that really, it sounds like a very orthogonal moment.
100%. Because it was really like the I'm going to end up dead or in jail, either because somebody kills me or I'm going to, I'm not proud of this, but okay, when I say like knives came out, it didn't mean they were pulled on me. Like everyone was involved in this. And I'm like, listen, I don't want to hurt anyone. So sooner or later I was going to end up killing somebody or getting killed or just, or in jail. And I'd been locked up once before. I'm like, that's an experience I do not want again. And I realized this is terrible. Like I'm not doing anything well. So that was the moment. And I had the benefit of, at the time I was paying Mike Menser, the bodybuilder. I paid him $100 to coach me and give me a program. And he kind of took a liking to me. So we'd have phone calls every once in a while where he was having me read a bunch.
How did you connect with Mike Menser?
I paid him. I read about a thing and he was like, this high intensity training is way better than everything else. I saw it in the magazines. I stopped doing the high volume work. I started doing 2 sets per muscle group each week and just grew like a weed. And I was like, this guy's onto something. Now, granted, anything probably would have had me grow like a weed at that point, but that worked particularly well. And then he was sending me books, Ayn Rand books.
Is Mike still alive?
No, he's dead. He and his brother both died of heart attacks. I think they were pretty heavy amphetamine users. But I remember him telling me
he's kind of the OG for that training format, right?
Yeah. And Dorian Yates had
Dorian
worked under
became,
him.
yeah.
And I heard he was a pretty outrageous guy. And he used to bark at me over the phone. And he was like, PhD stands for piled high and deep. But then he'd say, listen, you seem really interested in ideas. Don't be a moron. He said this. These are Mike's words, not mine. He said, don't be a moron. Don't be a bodybuilder. Don't touch steroids, right? Which I didn't. Even though they were around a lot in gyms at that point. He's like, you have a mind, develop your mind. And that had a huge impact on me. Him, Bob Peters, a high school football coach who taught me about weight training and running. Gary Hall, who's actually my lab operations manager, was a guy that I grew up with skateboarding, who told me early on when I was 14, he sat me down, looked me in the eye. He's a pretty tough love kind of guy. And he's like, look, your parents are really messed up. And so many of the people we know in skateboarding are super messed up. And he's like, if you mess up, I'm going to kick your ass. And then in the end, he moved away to Milpitas and I kind of just drifted off. But I remember that thinking, he said, it's not your fault, but if you screw up, it's your fault. And, we still laugh about that now. So, I think in those years, I started just realizing like discipline is the answer. I'm sounding very Jocko-ish now, but it was the answer. I needed structure, and the structure had to be self-imposed. So I got really into school. And then by the time I graduated, I graduated with honors. I had published a paper. It wasn't a magnificent paper, but the data were solid. And I got into Berkeley and Princeton for graduate school. And I decided to go to UC Berkeley. And I went to Berkeley, and I loved my time there, but the person I wanted to work with is Carla Schatz, who's now back at Stanford, amazing developmental neurobiologist. She developed the phrase fire together, wire together. Brilliant neurobiologist. I was hanging around her lab, and she moved to Harvard. So what I decided to do was move up to UC Davis, where she suggested working with a younger faculty member there named Barbara Chapman, who is my PhD advisor. Once I was in Barbara's lab, I literally ended the relationship that I was in at that time. I had met someone in Berkeley, wonderful person, but I ended that relationship so that I could just focus on school. And I literally lived in the laboratory. I'd bring my groceries. I'd train at the gym. I'd sometimes shower in the monkey cage washer. I was with the heat turned down, and I was just a machine. I would just work. We published a bunch of papers. I would just blast Rancid, Bob Dylan, classical music, tinfoil on the windows. I was just obsessed. Now, granted, I wasn't paying much attention to my emotional and personal development, but in terms of loving science and just focusing on science, I mean, I still, like, if I'm not choking up, I'm like, I literally feel my body like almost float. I loved it so much. And I adored Barbara. I absolutely adored Barbara. So then some things started happening along the way. I met Ben Barris, the first transgendered member of the National Academy.
You met as Ben or as Barbara?
Ben came to Davis to give a talk. He came into my lab and we started talking.
So this is what year?
This is 2002.
Okay. Yeah.
I was supposed to deliver him to a seminar, or 2001. And we ended up being an hour late for his own seminar because he and I were just riffing on science. I was like, this guy is the best. He's got this energy. I've always been pretty tuned into people's kind of enthusiasm and excitement. I feel like I can spot bullshit pretty quick. Bullshit meaning I've never been drawn to people who are purely ambitious. Ambition to me is kind of like, it's an algorithm that works, sure. But when somebody is in love with what they do, and that was why I love skateboarding. It was like, you don't survive long in that community. It's a harsh community. You don't survive long unless you love it. And the same thing with science. Like, I was in love with retinal biology, in love with developmental neurobiology. And I saw Ben's love of glia. I could care less about glia. Sorry, folks. They're interesting, but he loved glia. And so I think we resonated on this passion. He happened to be transgendered. I didn't even know he was transgendered, but we became friends. And then at some point I started going down to Palo Alto to teach his lab some techniques. And he said at one point, you should just do a postdoc in my lab. So
did you know you wanted to do a postdoc for sure?
I knew I wanted to do a postdoc. I decided in undergraduate, I want to run a lab. I want to teach students. I want to be a researcher, and I'm going to do it ethically and I'm going to do it honestly, but I'm going to do everything I can in my power to make sure that happens. And I looked up to Harry Carlisle so much. He drove a black truck, smoked cigarettes. Again, don't smoke. It's bad. I don't smoke anymore, but he drank coffee. I loved him. His wife was a therapist. She actually ran the therapy center at the psychology center at UC Santa Barbara. I was like, I adore them. These are awesome. I want to be that. That's what I'm going to be, and the fact that my dad was a professor kind of fell into that. Now over the years, I was still in touch with my parents. I think they were proud of my shift.
Yeah.
I still had a lot of issues to work out with them. My mom, less so. My dad and I would say we finally buried the hatchet in 2000 and I really think 2007. I was a postdoc so what happened was I graduated from UC Davis, took my PhD, took a postdoc actually at Harvard, but I didn't want to work for the guy. There was some personnel. I'm going to just come clean. I mean, I didn't actually start, but I was just sitting in on lab meetings, and the personality traits of this individual to me were repulsive.
Give me an example.
It was one observation. It was the way he treated a janitor with a stutter. And like, I've never been an aggressor. I've never started a fight in my life. But I think from a time I was in, even my mom will say nursery school, I've been kind of a advocate and protector of others. And I can still feel my blood starts to boil if I think about that interaction. It was a later after work interaction in the way that he communicated to somebody. And I was like, I don't think I can be here. I don't think I can do this, because if I'm like, I think like there's no way I can be here. Like this is not going to work. So I'm sure this is a good person at some level, but I just remember thinking like, oh no, like what am I going to do? What am I going to do?
So you've literally moved to Boston. You've committed to do a postdoc in this guy's lab.
Yeah, broke up with my girlfriend on the West Coast. I had a girlfriend at the end of graduate school. I purposely didn't date in graduate school. My conversation with people was, listen, I'm focused on work. But I had a girlfriend at the end of graduate school who was great, but broke up with her, moved to the East Coast because we weren't going to, continue into family making and that sort of thing. And I'm there and I observed some things and I just realized I cannot work for this person.
A couple of weeks into this thing?
I had not started yet. I was supposed to start January 1. This was November of 2005. So
you tell him I'm leaving.
2004. So I told him I was leaving.
Did you tell him why?
Well, I couldn't be direct. At that time, I didn't have the skills to be direct about that. I told him I wanted to leave and he said no. He said, you need to get therapy first. I'm like, well, I got loads of that under my belt, so that's not going to work. And then there were certain things in the interaction around my deciding to leave that made it
reinforced your decision.
I was like, this is not going to work. So I called Ben Barris because I had turned him down for a postdoc, and I said, I don't know what to do.
And did you turn Ben down because he was working on glial cells?
No, simple reason, he was in Palo Alto.
And you just needed to get away from the nest.
I did not want to be where I grew up. Listen, Palo Alto's a lovely place. Stanford's an amazing place, but I had so much developmental history there.
Yeah.
And I was like, that is the last place on earth I want to be. But then Ben, in his love of biology, I remember I met with him right before the holidays and he just said, come to my lab. You can work on anything you want. Ben was famous for working on glia, but when Ben was a graduate student in David Corey's lab at Harvard, David Corey worked on hair cells, hearing stuff. And he allowed one person, Ben, to do something different. And he said, but you have to pay it forward someday. So Ben was like, I'm going to pay it forward through you. You can come to my lab. You can work on anything you want. And I said, well, I want to work on this stuff that is related to what I was going to do at Harvard, but I don't want to compete with that lab. They're a big monster lab. And Ben was like, no, you have to work on that. And I was like, God, I don't want to work on that. He's like, you have to. Like Ben was a real fighter. He was from Jersey. And he was just like, my mom is from Jersey and I kind of have that in one side of my family. It was like fight, So I decided to work. There were 3 labs. So it would be me alone as a postdoc, this guy at Harvard, and a guy over in Basel, Boton Roska, who's doing amazing work. And we were all trying to figure out genetic markers for retinal cells. At the time, that was a big deal, and there was a big hunt for them. And my feeling was there's plenty to go around. There are God knows how many retinal cells, 40 ganglion cells, which are the output cells of the retina that connect to the brain. There's so much territory. Why don't we all just work on this? So let's just say I ended up getting my slice, and this guy at Harvard got his slice. He had a lot more people, so he got a bigger slice. And Botan's done that and so much more for visual repair. He and Carl Dijsselroth, who we both know, of course, have figured out ways to get blind people to see, putting light-sensitive opsins into the eye, and et cetera. So, I'm one postdoc, but it worked out well. I mean, my career worked out well as a PhD student and as a postdoc. And then I eventually got a job at UC San Diego, which is a great neuroscience program.
Before we leave that, give folks a bit of a sense of the difference between a PhD and a postdoc.
Yeah. So during your PhD, you're working closely under the mentorship of one person. That's also true in the postdoc. During the PhD, the requirements are learn the basics of the field and be tested on them in the classroom, learn the basics of experimentation and experimental design, and then become expert in one specific area by doing experiments. And then you get your PhD, I always say, by being expert in one very specific area. And you have to know everything about what you did and why, literally down to like what specific antibody you used, and where it is in the refrigerator. And you need to be able to do everything essentially that's on your papers. Learn the publication process, learn how to write, learn to take rejection, learn to take challenge in the seminar format, all of that.
And let's just also talk about what is an expectation in a PhD as far as publication?
So this varies. I mean, I did very well as a PhD student. We published, 4 to 6 first author papers in great journals. 1 to 2 would be sufficient if they're good quality papers. And some projects go better than others. I think the key requirement of the PhD is to become a true expert in one area and then to be able to frame how that fits into the context of the field as a whole. Your PhD thesis is given not for saying, I did this, I did this, I did this, which any technician could do. It's given to you for saying, I did this, I did this, I did this, and the implications are blank. The implications are blank. And to extend that into the discoveries of past and other laboratories. Once you can do that with some degree of mastery, you're ready to go. And typically that correlates with having 1 first author manuscript in a good journal, but not always. Sometimes it's 2, sometimes it's 4. I did my PhD in 4 years, which was pretty quick.
And half of that was in the classroom, half of that was in the lab, typically, or dedicated to the lab?
Yeah, typically you're taking courses only the first 2 years. Now, also there's some weighting here based on peer group. So for instance, I started my PhD when I was 25. I ended it when I was 30, even though it took me about 4 years. I had no children. I was dating, but I wasn't in a committed relationship for most of it. And I know people talk about this, I literally worked 12 to 16 hours a day. And I was not in the best health. I lived on Pete's black coffee, diet Mountain Dew, cucumbers, ground beef, oatmeal, oranges, and love of what I was doing. I just was, and creatine. I was, and athletic greens. Like it's true. I started taking athletic greens a long time ago. Oh no, that was 2005. So 2012, that was as a postdoc was when I started actually taking better care of myself. That wasn't an athletic greens plug, but I always say I'd started taking in 2012. So that was 2000 to 2004. And I was into vitamins and things like that, but it was just caffeine, drive, basic macronutrients. I worked out 1 day a week in the gym and I ran 1 day a week because
that's it.
And it wasn't good, right? I was young, so my body didn't fall apart, but it wasn't good. And I prioritized everything around work. So
what was the title of your dissertation?
It was neural activity and axon guidant cue dependent development of eye-specific segregation in the lateral geniculate nucleus, which is basically saying there are molecules and there are patterns of neural activity that govern brain wiring. And at the time I was working in ferrets and cats, so carnivore species, there wasn't a lot of and I wanted to move away from that. I've always been an animal lover. I had a pet ferret. I didn't want to work on large animals. I've done some non-human primate work, the fetal primates, fetal macaques, published a lot there.
How big is an adult macaque? They're still pretty small, aren't they?
An adult macaque? No, an adult male macaque can be, a couple feet tall.
Really?
Oh, they'll rip a limb off of you if you let them.
I didn't realize they were that big.
They carry herpes B, which can kill you. There's a famous case in Atlanta of the one splashing its pee into a woman's eye. She wasn't wearing the face shield. She was dead like 2 weeks later. Yeah. Yeah. You'd be better off having HIV or AIDS than herpes B from a monkey. I do not like working on macaques for a number of reasons. I don't any longer. Postdoc, you're not taking courses. You're mainly focused on research and you're developing your own independent research program. You're largely independent and self-driven.
And the purpose of the postdoc is, would you do a postdoc if you didn't want to have your own lab? How many people do a postdoc and choose to go into industry rather than choose to create and form their own labs?
Nowadays, about 80% go into industry, but now there are a lot more jobs for neuroscientists in industry, places like Genentech, et cetera. But at the time, there wasn't. Now, I think anyone that goes into academia.
And what defines the duration? At least in the PhD, you're tied to a very clear outcome, which is the thesis.
Yeah. When when you're ready to move on as a postdoc, because you generally have 1 or 2 papers and a story to take into a seminar. Both the PhD and the postdoc, the goal is to have a 1-hour seminar of your own independent work and the context it fits into. And you get hired
could I have an honorary PhD in some facet of Formula One where I can spend 1 hour
Sure.
talking? Yeah.
Yeah, absolutely. I think you've earned more than one. I mean, I think that the postdoc was great. I loved working for Ben. So what happened was in 2005, I moved back to the Bay Area. I'm like, I'm not going to live in Palo Alto. I live in San Francisco, and I was working in Ben's lab and loving it. I mean, I was one of many people in that lab. There were 30 people.
Sorry, what year? 05?
This was 2000. I started in 2005 and I finished in 2010.
So this means we overlapped in the Bay Area again. Because, I was there for med school 97 to 01. And then I lived back there in 06 to 08.
Yeah.
So just think that we would have passed each other on 280 or 101.
Yep.
And not known.
Yeah,
I love realizing people that I've become very close to. We cohabitated,
Yep.
and I worked in San Francisco. Of course, you lived there, and I worked there. But yeah,
I was living at Clayton and Parnassus, right near UCSF, the old campus, the hospital. And my sister was in the neighborhood and had just adopted my niece, and so I wanted to be there so I could spend time with her. Because my sister is,
and we spent so much time up there because my wife ran the Coumadin clinic at UCSF.
Okay. Yeah, I was a few blocks from the Haight-Ashbury Clinic, obviously very different clinic.
Yeah.
But famous because of the Manson thing. And if anyone hasn't read Charles Manson, Chaos, Charles Manson, the CIA and the secret history of the 60s, a lot of history there. But I was commuting down 280, working in Ben's lab, loving that. I mean, a huge, vibrant lab meetings that would last 4 hours or more. Ben was outrageous.
How big was the lab?
32 people. And run by a person with a face recognition issue. So you can imagine like it was hilarious. And yet the lab meetings were legendary. People would argue and fight. Ben could be very politically incorrect, which was hilarious. But at the time also was important for us to really have someone challenge us in these very direct ways. We were all politically correct, but he tended to be pretty outrageous. I mean, Ben said some pretty outrageous things. And I learned so much from Ben about just staying in touch. He called it the light, or the flame, like staying in touch with the love of biology and not getting pulled into ambition. Now, Ben was incredibly ambitious, but he just loved biology and I loved biology. And then something weird happened in 2000.
And of course, I had the distinction by just luck by the year I was in it, which was 97. Started Barbara Barris was our head of neuroscience and the professor, and
Amazing.
Ended the year as Ben.
Wow.
So he was transitioned during our year.
Amazing.
And I'm trying to think, even though that's more than 25 years ago, it didn't seem that unusual. And I say that in a way not to sound like, oh wow, look at how enlightened the medical student was. No, I'm not saying that whatsoever. It had much more to do with Ben.
I think does
Ben, that make sense?
Yeah, Ben, when Ben moved to the Bay Area, I know this because I ended up. I can get to this in a minute, but Ben ended up passing away in 2017, and I wrote Ben's obituary for Nature, and I sat with Ben for many hours recording conversations with him that I hope to someday release, talking about his history and the decision to transition and his thoughts on when and how best for people to transition, what that means, his relationship to sex, the verb, and sexuality, academia. And it's a great audio file because he tears loose on people in academia because he says at the beginning, is this for my obituary? And I said, yes. And he said, well, it better be for a good journal. And I said, it's for Nature. And he says, okay. And then forgive me for cussing, but this is a direct quote. And I said, and he said, well, given that it's for my obituary, I'm going to say whatever the fuck I want. And he really does. He lets people have it, but he also really expresses a lot of heart for the things that he thinks are important in science and in life. And I'm sitting there tears just running down my eyes, trying to get these recordings, and I'm quaking and and I realize what's happening. He's going to be dead soon, right? He had pancreatic cancer. And, as a non-clinician, that was pretty intense.
We had reconnected in 2012. He had read some of my blog stuff and reached out to me and became, interested in certain things that I was doing and asked if I would check his bloods and stuff like that.
He was really into data. Yeah. I mean, maybe it's worth saying this now. I mean, one thing that people don't realize about Ben is that he was always trying different diets. He struggled with his weight a lot. because he transitioned, he was taking testosterone, but he had always struggled with his weight. And he had tried keto, he had tried fasting, he had tried vegan diets. He was always sampling with different things. And he was always asking me about nutrition and supplementation. And I would tell him something like, hey, because when I was in his lab, I was working a lot. And I remember the fewer carbohydrates I eat, the more I can stay awake. It's just kind of how it works for me. I do eat carbohydrates. I'm a pure omnivore. I love starches, but I tend to eat oatmeal and rice and pasta, clean, quote unquote, starches. But at the time, he caught me drinking the oil off the top of the almond butter and then slugging back to espresso. And he was like, what are you doing? Like, you're going to die of a heart attack. And I was like, no, you have to understand, like, certain lipids can be used as fuel if you're not taking enough carbohydrate. And then he would scream, that's ridiculous. That violates all the rules of biology. And then that, by the way, was Ben's voice. I'm not mocking him. You can listen to a recording. And then he would come back to me 6 months later and he's like, I'm doing this low carb thing and I'm losing weight like crazy. How come nobody knows about it? And he was the one who told me. He said, forgive me, my clinical colleagues, and Peter, you don't fall into this category. He was like, most doctors are so unhealthy. He's like, they don't know anything. And he was an MD, right? Ben was an MD PhD.
Yeah.
And I remember him telling me, he was like, don't believe any dogma. Don't believe any of it. Like, Ben he had this heretical thing. And so you're sensing a kind of a theme here. I liked hanging out with like punks and skateboarders when I was younger, not because they were wild, but because they looked at things differently. They really did. I love stories like I loved the Steve Jobs book. I mean, I remember seeing Steve walking barefoot through the neighborhood when I was a postdoc, when I would visit my folks in Palo Alto. And my high school girlfriend, that girl that I met at the skateboard shop, she was his vegan chef. So, and her sister worked for Steve also. So it was very like Palo Alto themes. And he was kind of a punk rocker and didn't even realize it. You know, my heroes are people like Joe Strummer, Oliver Sacks, people that really went against the grain of their field out of love, not as an FU, right? And Ben just loved what he loved so much. But when he started working on glia, everyone thought glia were stupid. It's like support cells. Why would you do that? And he showed they're important for everything, disease in particular, but also normal brain functioning and development. So Ben was the one who really encouraged me to stay in touch with that kind of feeling around doing things and to never let ambition pull you in a direction where you were divorced from that for too long. And yet he was also an extremely hard worker, but he understood that that's what Rick Rubin would call the source. Like, that's the ability to stay working long hours and not feel like you're depleting yourself. So Ben and I got really close in those years. And then that I was working for him, but he was healthy then as far as we knew. And then during those years when I was working for Ben, I wasn't making enough money to survive in the Bay Area. I was really struggling.
What's a postdoc salary?
I had a Helen Hay Whitney fellowship, which is a kind of a premier fellowship from a private institution. I only say that because they pay more, and I was making 45, but rents were crazy and gas and food and everything else. And as a 45K living in the Bay Area was rough, and I didn't have kids. So I actually went back to Thrasher magazine. I had a bunch of friends that worked they're located in the only truly dangerous part of San Francisco, Hunters Point. And they gave me a job writing articles for Thrasher and Slap magazine, the sibling magazine. And so there are a bunch of articles out there. I was writing under a different name.
Oh, you were?
I was making money.
Why under a different name?
I was used the name Andy instead. I don't know, because people in skateboarding knew me as Andy.
Oh, okay. But same last name.
Yeah.
Okay.
Yeah. So, and I was writing articles on music and bands and going to hear bands play, and then getting back to the lab at 2 or 3 in the morning, sleeping in Ben's office, and then working the day and that whole thing, and making maybe an extra, $500 to $1,000 a month. But it was great. And I was getting to go to shows for free, getting to know musicians, falling back in with the skateboard set a bit, all the ones that were healthy and now had families and jobs, all the other stuff got pushed away, all the dysfunction. So I was in both worlds again. And then eventually I got a job at UC San Diego. I was picking between a job there and MIT. And my previous experience in Boston, I love Boston. I love the academic community there. But it was like, I'm a California kid. I'm like a skateboarder and punk rocker at heart. I had this one interaction with someone there before in the academic community. I thought, back there, everything's focused on lineage and how old you are and how long you've been around. And in the Bay Area, it's all about the young tech, and youth is really valued. You could be 25 years old in the Bay Area, and if you have a great idea, people don't care. Yeah. The East Coast is different. At least at the time it felt different. So I went to UC San Diego, and my lab flourished there. And then eventually
you got to San Diego in 12.
I was hired in, officially started 2011.
Okay.
And I left in 2015, mostly because I got hired back to Stanford when Ben was still in the department. Now, the weird thread through all of this is that when I was a graduate student.
Where did you live in San Diego?
I lived in Normal Heights, near kind of out towards El Cajon. I went from making $45,000 a year as a postdoc. I started my job, just so people know, I'm not shy. Professors make about $100,000, $110,000 as assistant starting a professor. And I went from having essentially no responsibility. I bought a little house. I could afford like this little house. I got a bulldog puppy and I got a laboratory. And I hired a technician that I knew from Davis, and we just went ham. We were just experiments. I lived in the lab 2 or 3 days a week, brushing my teeth in the sink. My students were like, what's wrong with this guy? But we were very fortunate. We published a bunch of papers in great journals. More importantly, we were having a lot of fun doing research. I had all these microscopes. I was like, my name's on the door. I can't believe this. And I didn't care that my name was on the door. Actually, I've always thought that labs should name themselves after the work they do, as opposed to the name, for a number of reasons. I was having so much fun. It was incredible. I met a woman there that I was in a 5-year relationship with somebody there that was really wonderful, who also taught me a lot about kind of how to balance my professional life and my personal life. Despite that relationship not working out, there was a lot of important elements of like teaching me like, hey, it's good to come home for dinner with me and the dogs every once in a while, and taught me some self-care. Got back into doing some boxing, although I tried not to spar too often, as you're the fighter, not me. And I loved my time there, but the challenge along the way, the challenges persisted along the way. Challenges of youth. And I think that as much work as
meaning the demons of your youth were still rearing some of the emotional damage.
Yeah. I think that and that would show up in various forms, but I think, my dad and I finally put to rest our challenges in 2007. He had written me a letter that was expressing some concern and disappointment in the ways we were relating, but mostly concern. And I remember reading it and thinking, this is when I was a postdoc at Ben's, in Ben's lab, and thinking like, he's reaching out. This is years after everything, right? Maybe it's time to take a look at this. But I wasn't about to try and solve it in a conversation. So I was like, if you want to do some work together, like, let's go to therapy. Let's have a conversation in front of somebody who can really like tell me where I'm wrong also. And we did a total of 4 sessions, I think, with a really excellent female therapist who, and I remember the question was, who was going to pay for it? And I told my dad, I'm like, I don't have much money, but I'm going to go in 50-50 with you on this one. And that was important to me. So we did this. And after 4 sessions, we realized that, I think it was the first kind of like true, like man-to-man conversation we ever had. And I realized that, a lot of the things that I would struggle with growing up, he had struggled with too.
Meaning his life growing up as well?
Yeah, his relationship to his mother, his relationship to himself, trying to balance a life in science and ambition, which is tough. I mean, science is not, they're not throwing punches at your face. They're not shooting at you. But you're also not winning millions of dollars at the end of a case or cashing out a big IPO. And so the wins are really like wins of the heart and wins of discovery. Like, not to sound sentimental, but you get a paper in Science or Nature. I'm blessed to have, more than a few of those. And the first time you get it, you're like, shit, will I ever do that again? So you're a lot like a professional athlete, but your world is tiny. And once you realize that your world is tiny, you have 2 choices. You can either leave because it's too small, or you can go back to your love of the work. But then you also have to live in the world and have a family and relationships. And so in those conversations, I think I realized, I was like, wow, I inherited some real gifts from my dad. Curiosity, love of craft. He's certainly driven. My dad's almost 80 now, and he's still firing on 8 cylinders. He's excited about cars. He's excited about science. He's excited about movies. He's excited. He's just got so much going there. And we resonated. We finally hit that point. And that was good, Again, I think a few times this discussion, I unexpectedly have to fight some emotion back. But I think it's that, when they say forgiveness is really the best thing, I think it really is. And we're good. We're super close. And then in that time in San Diego, I went back into just full forward center of mass ambition. And it was really only the girlfriend that kept me a little calibrated, and my dog, my bulldog. And something happened in those years. So when I was a PhD student, I published this paper. Second paper I published was published in Science. I was super proud. I was excited, science paper. And I called Harry Carlisle in San Diego and told him, I was like, hey, because he'd known my story, and he kind of took me out of not doing much gave me a lab to work in. He saw me graduate with honors. I went off to Berkeley. So he was tracking my career.
Because he had gone from UCSB to...
No, he stayed at UCSB. He had been my professor down there. So he was like, congratulations, next time you come through, you should have a pizza with me and Jane, his wife, and we can catch up. I'm happy for you. And then 3 days later, he shot himself in the bathtub, just killed himself. And I was like, whoa, like that was like, so I was down there 2 days later or 3 days later speaking at his funeral. And I was like, holy shit, and I'd known a bunch of people that had died or gone to jail from the skateboarding world. That was like it was just crazy, because this was the guy that had taught me about mental health issues and about depression and how it's all neurochemistry. And it turns out there'd been Jane and I would meet for the next couple of years. I would go to their house and talk to her. And she recently passed away, but she told me that they had a son who had died in a motorcycle accident early on when he was in his teens. And Harry never quite got over that. But anyway, he should have known better. So I realized, I was like, wow, you can have all the knowledge in the world about the underlying biology, and it might not save you. So that was kind of like a wake up call. And then what happened was, when I was in San Diego, I was very, very close with Barbara Chapman, my PhD advisor. She had 2 kids while I was in the lab. My niece was friends with them. Our families were kind of merged, and she started falling out of communication with people. And she ended up early onset breast cancer, died, which was insane. So now I'm speaking at her memorial at the House of Flowers in San Francisco. She's got 2 young girls, her husband I know. And I'm like, geez, like this is crazy. Like, and that one was, I have to be careful I will cry if I talk, which I prefer not to do if on camera, if I can, not just cause it's distracting, but that was horrible. That was like losing my mother. Like, it was just like, and I was like, what the fuck? She had the BRCA2 mutation and the BRCA1 mutation. So highly susceptible to cancers. So then I got through that, but that certainly destabilized me. I reacted to that by just working twice as hard, which was not a good formula. I get to Stanford. I get hired back to Stanford. I go out.
Which I'm sure a big part of what makes that great is you're now a colleague and a peer of Ben's again.
Yeah, next door laboratories. Right. Next door. I go out to dinner with Ben Barris, Carla Schatz, Krishna Shenoy, and and Karen Harush. We were at Il Fornaio, downtown Palo Alto. My first week back, I'm sitting across from Ben just like this, and he looks at me and he says, I think I'm having a heart attack. Now he's an MD, so I literally take him in my truck, my 4Runner, drive to Stanford Hospital, and we spend the night talking. And he's like, don't tell anyone in my lab. I don't want anyone to think I'm dying or something. Later that week, he has a second heart attack. He's throwing clots. So he was diagnosed with pancreatic cancer. And so from the moment I land at Stanford, I'm watching my third advisor die. And at that point, I was like, okay, like Ben and I used to joke, he's MD, morbid sense of humor. He's like, and he called me Andy. Andy, you're the common denominator. So the joke is you don't want me to work for you, right? But I had a conversation with Barbara before she died, which was crazy, right? Super powerful, but you're just like, you're saying, I don't know. We're talking yesterday about hospice, people who work hospice, like saying goodbye to someone's tough. Hearing that somebody went suddenly is tough. Saying goodbye to somebody is tough for a whole other set of reasons. Luckily, her daughters are both doing really well. One graduated from college. The other one is a neuroscience student at McGill, which is awesome. Makes me so happy. Ben passing away was kind of the final nail in the coffin for me. I was like, okay, I need to actually like go all the way back and start doing some deep excavation, because what was happening was I was starting to just like feel really shut off. I hated doing my work. I thought I might write a book.
Meaning you were losing love for science.
I was losing the touch with the source. I was working, but I had this big lab. I wasn't feeling it. I was like, and I started kind of foraging. I started doing cage exit great white shark diving. real smart, right? Might as well box 9 rounds with you or with like a real fighter, like with no headgear, right? Like I started engaging in dangerous behavior again. Started running risks in life again. And here I am, I'm a 42-year-old man with a tenure at Stanford in a lab, and I'm publishing. We published a full article in Nature in 2018 after Ben's death. And I just remember feeling like pretty joyless and thinking like, what the fuck am I going to do? Forgive my language, but just like, what am I going to do? Like this, I'm out of touch with all of it. So a couple of things happened. One was I went to Hoffman. I did the Hoffman process, which is a pure, no drugs, no psychedelics, but it's that kind of psychedelic like state of self-actualization stuff. By the way, anytime I mention something like Hoffman, I realize that these are like, I think it's $4,000 or $5,000 for the week. They have scholarship programs. I've given some money recently to their scholarship program. I think it was helpful for me. But one of the things that really helped was I went off and did a week-long trauma immersion thing in 2017 on the East Coast with a brilliant guy named Brian Suave, who does trauma-based work. So I was still trying to work through some old stuff, and it's hard to know, right? You amass a childhood experience, you amass some adult experiences of major loss, and yet your career is going like, who knows what's what, right? And listen, I mentioned it probably in this conversation, 3 or 4, maybe more girlfriends. Like it wasn't like I was somebody who enjoyed skipping from relationship to each one of those is a story of kind of like hope for a permanent future, and then a cliff. So I was dealing with that too. And again, I'm the common denominator, right? I mean, I'm not going to take all the blame, but there's a consistent variable there. So what happened was in 2017, I went there and I met a guy named Pat Dossett at Hoffman. He was at my graduation, and he done 13 years in the SEAL teams, and we became friends. And through
this was in 2017.
And through going down to LA where he was living and starting to swim with him and hang out with him, it was in the turn to 2019. He said, what are you going to do for the world in 2019? That was this kind of seed question. And I was like, I don't know. What I would do is I would probably like post 1-minute clips on Instagram about the retina or nerdy stuff that I think is really cool. So he was like, do it. And I was like, okay. And he's like, no, shake on it. Like SEAL team kind of guy. Like, okay. So we shake on it. I start doing that in 2019. And then 2020, the pandemic hits. And I thought maybe I'd write a book. And then I realized, oh, well, my lab works on stress, and I've got some tools for stress and improving sleep. I'm not going to talk about vaccines because that just seems like a barbed wire topic. People are losing jobs for that. You can't win that conversation. At the time, it felt crazy, and it was. And I thought, I'm not a virologist anyway, but I'm just going to teach stuff by going on podcasts. And 2020 started with one podcast. I did 30 podcasts that year. I went on about 30 podcasts and went on Joe's podcast, Rogan's podcast and Lex's podcast. At the end of 2020, Lex was like, you should start a podcast, but don't make it just you talking. So I took half of the advice. And in 2021, I hired the guy that was going to PR me for my book stuff, Rob Moore, and we started the Huberman Lab podcast in 2021. Which
God, is it?
It January
seems so much longer ago.
Well, I think because 2020 I was going on podcasts. 2019 I was blabbing into Instagram, and I'll tell you, during those years I was so frightened. It was like 2019. I just thought, gosh, I hope none of my colleagues see this. But if they did, everything I'm saying they know is true. I just hope they don't see it because they're probably be like, why is he on Instagram? I mean, I might as well have been on TikTok. Probably the only reason I'm not on TikTok is that Stanford forbid us from being on TikTok early on. They said it was a security risk, which it was and is. Yeah. So that's why I'm not there. If you see me on TikTok, that's not me, or it's me, but someone poached the videos. So 2020, I was just really concerned for the world. Frankly, I was like, listen, I know the guy who's the director of the National Institutes of Mental Health. I don't see one soundbite. Sorry, Josh, but like, I don't know you well enough to kind of poke at you, but if it wasn't him, no advice on get regular sunlight, stay on a circadian rhythm, learn some stress mitigation techniques. It was like, and the world's kind of falling apart due to stress. And I'm thinking, okay, no one's going to step up. I'm just going to do this. And I wasn't selling a book. I didn't have a podcast. It was just giving information. And then when the podcast started, I remember thinking, I really want to honor the incredible place that is Stanford. I never want this to look like something that is the same as being in a class at Stanford, but I'd love it to incorporate some of the brilliant minds that are at Stanford. So I just invited a bunch of my colleagues on. Carl Dicer,
Yeah, Carl was one of your first guests.
One of my
right?
first guests, and Anna Lemke and all these people, and just showcasing, put a spotlight on other people. And then this last year is where the funds really started for me, because I could start to include people that are of some of my other longstanding interests, like Andy Galpin on fitness, or Lane Norton on nutrition, and things that relate to other interests of mine, but still keeping it in a scientific frame. So, and throughout this whole time, I have this weird journal where I have conversations with different people, including you and Rick Rubin, are people who, some other brilliant minds that we know, and I take notes on those conversations. And I also keep conversations I have with Barbara, and with mainly with Barbara and Ben, although mainly Barbara. And this isn't like writing to someone who's dead as if they're there, but I try and take every major decision and kind of stance around podcast, or stance around research, or what to do with my lab, and filter it through what I consider important lessons that I've learned from them. I still do therapy 1 to 3 times a week, because if I didn't, who knows what would happen. And then I've talked about this on previous podcasts. I have done some exploration of the psychedelic space, although not a lot, and always in the company of a physician. And 2 of those sessions, for me, it was MDMA, were immensely beneficial for allowing me to have a conversation like this, or to be a better, to put my dog down with my own hands and know that I was doing the right thing, who I was super close to just kind of register what's important. And I have to say, if this is just my life and my life arc, but if there are any lessons in it, it's very clear that, like, staying in touch with the things that give us energy, as opposed to being ambitious for ambition's sake, like really getting the order of that dialogue correct, and putting love of craft first, and letting ambition stem from that. And also just friendship and amazing mentors. I mean, in the podcast space, I remember thinking Tim Ferriss, listened to his podcast early on and read his books, Joe Rogan, you, Lex, Rich Roll, Rhonda. Yeah, I always joke, first man in was actually a woman. It was Rhonda, right? Like that array of people, long before I knew any of you, it was like, these are the Ben Barris's, the Richard Axels, these names are of the podcast world. Like these are the greats of my field. And so I pay a lot of attention, like, what are they doing? How can I do things well like them, but different? Because in science, like in podcasting, there are no rewards for just imitation. There really aren't. The beauty of podcasting relative to science is that if you and I have the same guest on in 1 week, it raises it in the algorithm. Whereas in science, yes, if 2 papers come out simultaneously in a journal, that lends strength to the argument that the data and conclusions are true, right? Because 2 discoveries independently. But there is this notion of scooping, right? If you publish a result in a given arena and then I'm 6 months late, I can't get it into a good journal. Podcasting, it's the opposite. If Joe has David Goggins on yesterday, I think he did, and then he comes on your podcast or my podcast, it's just the rising tide raises all boats, and the algorithm is the tide. And so in that way, I feel like, wow, like I'm in a field, I'm still run my lab, but I'm in a field where like goodness grows goodness, and sharing and being generous just makes everybody succeed more. And you learn from seeing how someone relates in other conversations. So I don't know, whatever deadening was created by the death of my advisors, and from all the backstory and all that stuff in 2020, and especially in 2021. And it was that conversation with Lex, but all the other stuff that led up to it, it was just like rocket fuel. It's like, right now, I truly say, if you gave me $100 billion to stop podcasting, I wouldn't do it. Because to me, what I know for sure based on my experience is that at some point the lights are going to go out for me, dead, just like gone. This as a physician, people don't like to think this way. It's going to be lights out, and it's sort of like, what are you going to have? And what you have done. And so I really feel like, as much as I can touch into like the beauty and utility of biology and share that, then I'm good. The rest is just noise.
We think about like kind of the sort of meteoric rise over the past 2 years for your amazing work. What do you think you're going to be doing in 2 years?
Podcasting.
Well, given, but
I hope.
with respect to a lab.
Yeah, so we have a paper that's right on the 99.9 yard line that this morning, there's one little thing they want us to tweak before it goes in. This is a cell press paper I'm really proud of on breathing patterns and anxiety. So we're still publishing. We have another paper that we're fighting at another journal right now, as is often the case. My lab has got necessarily smaller because of podcasting, but I have a close collaboration with David Spiegel, our associate chair of psychiatry, and we are spinning up a number of programs at Stanford around mind-body research. He works on clinical applications of hypnosis. Nolan Williams with psychedelics. I haven't talked too much about this publicly, but all our podcasts are free. We release them every Monday, sometimes Wednesdays as well. But we did launch this premium channel. And the purpose of that premium channel was, thanks to Andrew Wilkinson and Tiny Capital, there's a matching of funds for people that subscribe to that. This isn't a pitch, but this is just the case. What I'm trying to do is raise money to fund the best work. And so I really think in 2 years, I'll be podcasting. I'll still be a professor at Stanford, still teaching. I teach next quarter, in fact.
You'll be teaching the same course that Ben taught me.
Right. NBio 206, which is neuroanatomy, and also it's functional neuroanatomy. So all the system, everything from addiction.
It's an amazing course.
It's a fun course. And
I'd love to take it again, given that I literally probably remember 2% of it. It's a shame.
I'm sure we can figure out a way for you to.
Could I audit it?
Sure. I'm the course director. So I say yes. We'd be honored to have you. That'd be amazing. So seriously, yes. I'll give you the schedule. It starts soon. But I would like to get more involved in science philanthropy, and in particular to fund research on humans. I will say I'm very frustrated with the lack of progress in translating animal models to human treatments. I know it's necessary. It takes time. I love the worm work, fly work, mouse work in particular. There's also a place for primate work, although it's the thresholds for that are higher, given the animals they are. But human work right now, there's some excellent human work that really needs funding. And one of the things I experienced firsthand was we were always well-funded and still are, but the frustration of wanting to do the coolest thing and having to take 5 years to ramp up to do it. And meanwhile, there's a lot of suffering. There's also a lot to be gained from doing these studies right away. Stanford obviously has great channels for raising funds for doing that kind of high ambition, high output work. But I think I'm in a unique position to be able to understand the life of the researcher. And put simply, the last thing a researcher needs to do is spend time writing all the justification. What we're doing is we're creating a system where someone can literally type out no more than half a page in 11-point font, give it to us, and we give them money to do the work in the hopes that that will accelerate the process. So raising funds for that through the podcast and more generally doing philanthropy is really important. And I've always hoped that at some point I could shape science policy a bit, but the things that really need shaping, make big differences in discovery and curing disease in laboratories, is very simple. And I wish it were a different word, but it's money. Money's necessary but not sufficient to make progress. More money gives you more opportunity to try things. Simply what it is. There's never a case of too much money for doing research. There's sometimes a dearth of excellent people, but that's not a problem at Stanford and other places, right? Of course, Stanford's not the only great place, many excellent places. But the more money that can go into research, the more progress that will be made, period. So I see myself podcasting and also being a really strong advocate for directing money into research. And also, we're losing a lot of graduate students and postdocs and potential graduate students and postdocs. There's a big strike right now in the UC system because they're paid garbage. And many of them have kids, and we're going to lose entire generations of great discovery. And so what I'm also trying to do is create endowments so that we can pay people a reasonable wage. I mean, I chuckle because it's just insane. Most of the people that are holding the power to make these decisions wouldn't live a day with that amount of money in their bank account, because it would give them an autonomic shock to just know that they were not necessarily going to make it into the next week. So I feel very strongly about give people resources that allow them to flourish. This is very Ben Barris-ish. Give people resources that allow them to flourish, that allow them to stay in touch with the source, if you will. And yeah, I mean, if I can raise $1 billion for research in the next 2 years or 5 years, not just through the podcast, and I'm podcasting, if I have to shut my lab, I do. but I think I'll have a greater impact on science and discovery than if I'm there writing my next R01, which I just completed a revision anyway. So that's the long answer.
So I had 6 pages of single space type
Not
on
a single
things
one.
that we were going to talk about. We talked about let me see how many we talked about. 0. We talked about exactly
Sorry, I
0
apologize.
of these. So the implication, of course, is when are you coming back to Austin so that we can actually do the podcast?
Anytime you'll have me.
All right, so great. We'll sit down again in a month.
So this could be a part 1.
Yeah,
perhaps.
yeah.
Okay.
I want to end with sort of a philosophical question that touches on a theme that you mentioned. So we talked about how there's really a sort of renegade skater spirit that exists in some of the great minds. And, we keep throwing around our friend Rick as an example in the creative space. But, we talked briefly about Richard Feynman, who we didn't even get into some of our stories about Feynman. And so there's no question that you need people who are willing to question everything. I mean, it's no small miracle that the Apple campaign of Think Different was arguably one of the most successful ad campaigns of all time. But we also have to reconcile that science requires a lot of fundamental knowledge to even give you the privilege to think differently. Let's not forget, before you do the PhD, you've done 4 years of undergraduate coursework, which admittedly is mostly learning an existing body of knowledge.
Correct.
You then spent 2 years doing a PhD where you're learning an existing body of knowledge in a much narrower area than your undergraduate, but at a much deeper level.
Mm-hmm.
You take a comprehensive exam that we didn't even talk about how challenging the comps are before you, depending on the university especially, before you even earn the right to now go sit in the lab to start to think different, which, by the way, is essential. If you go into the lab, you can't, by definition, have a PhD thesis that's the same as somebody else's.
Right.
You're not going to get it. It has to be unique work. And to me, I think what's very difficult about communicating science in the public is that line is difficult to explain. And it's very easy in social media, for example, to just assume everybody's an expert. Like, there's no real ability to distinguish between signal and noise.
Right. Or assume that if somebody got something wrong, that they're wrong about everything else they're saying.
Yeah.
Which is certainly not the case.
So, I was interviewed on a podcast recently and someone posed the question to me around this. And, I didn't have a great answer. I think of, like, if I think of my purpose in that sense of source, I think of it as hopefully just getting people to think about things and hopefully providing them with enough substrate, both in terms of the knowledge and the mental models and the frameworks and the ability to have some of the critical thinking. Then they're being armed with a tool that will allow them to look at the world and look at other claims and stuff. But to be honest with you, I have no idea if I'm able to do that. Like, it strikes me as a very difficult thing to do. So my question is not about anything that I'm doing. It's more about, how do you see your role in addressing, I don't have a better word for it other than what's going to sound a little bit crass, which is just a crisis of scientific literacy, and a crisis of scientific literacy that has led to a crisis of confidence.
Yeah. Well, first, I just want to say that not only are you getting people to think differently or think a bit more deeply or a lot more deeply, you're also giving them very useful information. And you're being humble, and I understand it's genuine, but I do want to say that as a consumer of your information, but also as somebody who pays a lot of attention to the landscape of the space, the impact is real and it's significant. And I've long been interested in the kind of the common themes between different movements and cultures. And I watched it happen in skateboarding. I knew well enough to know that I wasn't going to play a major role. I probably could have run a company or been involved in that. Although with my social and professional skills back then, I mean, I've seen fist fights in the offices of some of these companies, but some of them are worth many hundreds of millions of dollars now. And they run like, beautifully because it's a family feel. So a lot of that kind of craziness of the past is kind of no longer around. They have HR departments and things. But also the landscape of science. I realize there are people that are in this just for ambition. There are people that have real passion like Ben and ambitious and everything in between. And likewise within the social media sphere, right? And health education, you're seeing people that are just compelled to do it because they love it. They are also ambitious. You see people with just pure ambition. You can tell they're just grabbing onto every recent event as a way to get some views and likes and grow their channels. Their fate is obvious to me over time. I'm not being cynical, but it's just, you look at any other endeavor like music or art or science for that matter, you know where that's going to end. It's just going to end. They're going to flame out, as we say. I think that in thinking about these different universes or cultures, the human aspect comes through. And I think it at least gives me one answer to your question, which is, what are we trying to do here? Like, what are we actually trying to do? So for me, I have several things that are really like mantras. I want to communicate the beauty and utility of biology. I want to do that by being a teacher and to some extent a storyteller, but a story about biology. And I want to be a giver. I just want to give. Now, you raise an important point, which is formal, rigorous education often involves not doing anything creative. But it is
especially in biology. I mean, right. I think this is the difference, right? Sorry to interrupt you, but in mathematics, that's not necessarily the case. Like Ramanujan didn't have the formal education. It wasn't necessary. He was able to derive the insights from Gauss to Newton to Euler all the way through. And he, in the dirt, was literally coming up with the creative insights. And that is why mathematics and science are actually fundamentally very different things. And especially in biology. There's no discipline of science in which this thing that we're talking about is more present than in biology. The fact set is unbearably large.
It's unbearably large. And unfortunately, as Feynman pointed out, Feynman pointed out that unfortunately, taxonomy gets you nowhere.
That's right.
Just knowing the names of things, something that humbly, I'm very good at. I can memorize the names of things, many orders of magnitude beyond what is necessary or useful, right? I can tell you that we could have sat here and I could tell you the 20 or so different kinds of ganglion cells in the retina, how they code visual space, what they inform the brain likely or not. And the only thing that would have mattered is for you to understand that some cells sense motion, some cells sense contrast, some encode color information, and that it's built up in kind of a hierarchy pyramidal model to give you something like face recognition. That's all that matters. It doesn't matter if it's the alpha cell, the beta cell, the theta cell, the schmata cell. It doesn't matter. The names don't matter. In biology, so much of it is showing some degree of ability in the taxonomy. Okay. Is it useless? No, because it sets up a common dialogue. That's why taxonomy is useful. It allows different people in different labs to communicate, but it doesn't teach you rule sets. So if we go back to, I don't want to get back into prefrontal cortex per se, but let's think about the Stroop task. If I give you letters and numbers in different colors and you have to do that, you can't do the Stroop task if you can't speak the language that's read or recognize that 7 plus 7 is 14, right? 7 plus 7 equals 14 is just true. That's not changing. There's nothing creative about it, but you can't come up with alternate rule sets if you don't have the basic substrates, the basic building blocks. So I look at an undergraduate degree or even a high school degree and an undergraduate degree as developing the raw materials from which to then start resampling those raw materials, which is the PhD, into hopefully what is truly novel. But many PhDs are truly novel, but not terribly impactful for their field. Most PhDs, in fact. And most postdocs, it's like your attempt to do it again to show I can do it twice.
Yep.
That's basically it. Then you get your own laboratory. And there are some labs that survive very well by just kind of turning a crank and doing the same thing over and over again. The fundamental discoveries come from people really taking risk. So I think in the social media space, there are a couple of different issues here. One is, do people need to have a formal, rigorous education in something? I would say yes, but we need to put air quotes around formal. You look at a guy like Rick Rubin. I don't know what Rick's undergraduate education was in, but I doubt it was in music producing.
It was in something
but his formal, rigorous education is in the real world of producing music.
Right. But again, I think if we limit this to science, it gets more complicated.
So in that case, I think I would hope that the young person out there, or even older person out there who really wants to get good at science and scientific thinking, put themselves through the hard filter that is a formal, rigorous education in that thing. The beauty of looking at things through the lens of biology or through the lens of science and experimentation is that really at its essence, your goal is to falsify your own, what you think are best ideas.
Right. And then this gets to the complete other end of the spectrum so that the listener doesn't assume for a moment we're just sitting here being elitist saying you shouldn't be the ones talking about science if you don't have a background. I'm going to bring it right back to Ben's comment to you when he had his epiphany, which is the medical profession doesn't know that much.
Well, exactly. And I think that, I can't speak for Ben, but I do remember most of what he said, to me anyway. And it's very clear that scientific literacy in the general public does not require a formal education in science. I think it was Max Delbruck that said, assume zero knowledge and infinite intelligence. I think about that all the time. I believe that people are curious, and that if you give them the raw materials to understand what you're about to tell them, they can understand pretty much everything. I know there's the whole Feynman quote of, if you can't explain it to a 6-year-old, then you don't really understand it. That's true. I also think that you can take adults or younger people and educate them. You give them a minimum of nomenclature, and you emphasize that the nomenclature isn't really the point, right? We called it prefrontal cortex. We could have called it green monkey tree. Doesn't matter. It's in a rule set, context appropriate setting machine in your brain, and it's behind the forehead. Doesn't even matter, it's behind the forehead, but it helps you remember prefrontal. Okay. So what's important is the algorithm that it uses. And I think that in biology, we're always talking about processes. And so one thing that I think is really important and can be communicated to the general public, regardless of educational background, is that most of the time when you're paying attention to science, forget the nouns, focus on the verbs. Right? You want to understand how the brain wires up, maybe a discussion that we can have next time, or axon regeneration. Forget that it's an axon, just kind of understand an axon is like a wire. Okay, that helps you visualize it. But I can put in your head the ideas of a number of different processes that are involved from going to from sperm meets egg to a baby and a brain. Why? Because it's a bunch of processes that when you understand one of them, you can more easily understand the next and the next. Taxonomy doesn't do that. If I tell you that brain area is called that, it doesn't give you one shred of a hint of what a different brain area is called at all. In fact, it probably confuses you. So in many ways, teaching the verbs of biology is what I think is necessary. And I've started even doing this in the public discourse that I'm involved in. I've talked about the importance of getting morning sunlight. Why low solar angle sunlight actually has more yellow-blue contrast. And even though you don't perceive it through these cells, you look at it through cloud cover, you see that yellow-blue contrast is what activates the cells in the retina. It says it's morning. When the sun's overhead, no yellow-blue contrast. You can take a picture of it with your phone and see sunset, yellow, blue, and orange contrast activates these cells. So what do you need people to understand? You don't need to see the sunrise. You need to see the sun rising, the verb. You don't need to see it cross the horizon. You need to see it when it's low in the sky. If they hear that and they then remember, oh yeah, because that's when it's yellow and blue. Now it doesn't matter what the ganglion cells are called, melanops and schmelanops, and it doesn't matter. What you've got them on is a verb. And when you teach people the verb action of biology, I believe they start to understand the real mechanism and the real utility. And then the nouns, kind of, forgive my language, no one gives a shit. Doesn't matter, especially not to the general public that's mostly trying to just think about health information. We saw this during the pandemic. The problem with the vaccines were these cute little things of like, okay, here's the viral, not cute, but ominous little spiky thing. And here's the spike protein and this and that. And they show these little movies. And you know what people really wanted to know? They wanted to know, how do I know it's going to be safe? And what kind of safety is it going to afford me in terms of my health? Like, what are the probabilities? And then even when you told them that, a lot of people were still kind of standoffish about it. And then there was this.
Well, actually, I think you just hit on a very important point, which I would argue that someone asked me this question also recently, knowing my love for mathematics. Would the world be a better place if everybody knew calculus through freshman calculus in college? And I said no. But the world would be a much better place if people knew freshman statistics and probability through freshman college.
That's right.
That's what's missing.
That's right. And the way to understand statistics, of course, you have to understand the mode, the medium, et cetera, the mean, the median, and the mode. But what's really important is once you understand standard deviation, you don't care if people know what 1 or 2 standard deviations from the mean is. You want them to know what it represents. In other words, there's a verb in there.
Well, you also want them to understand what probability means.
Right.
A 2% chance that something is going to happen, what does that mean? Because that thing is either going to happen or not going to happen. There's a binary outcome. Let's just make it simple. But how do you imagine that a priori? How does expected value fit into that? And that, I think, gets to this point you raise, which is, it is important. And I think that's why so much scientific communication got destroyed during the pandemic. Is you had the people who were in charge treating everybody like idiots. So they didn't want to take the time to explain probabilistic things. Is the vaccine safe? Yes, it's safe on average. Is there any chance of an adverse outcome? Of course there is. There's a chance of an adverse outcome when you take a Tylenol or a baby aspirin. Mm-hmm. And we have to be able to sort of talk through that. And I guess that's the thing that just keeps me up at night is like, why can't we introduce nuance when it matters and not be fooled by noisy nuance that doesn't matter, which people like mm-hmm. to interject as a way to, at the worst, hide their nefarious intentions, and at the best, miss the point.
Right. No, I think that people were treated like idiots during the pandemic, and they responded in a very angry way. And when you treat people like idiots, they act like idiots, or they get angry, or they think, or it's like a teenager who realizes that their parents don't understand anything. When people start seeing a lot of flip-flopping in messaging, I think that when people understand or at least can visualize or experience the verb action of biology, they are forever changed.
Yeah, that's an interesting
If I give you 50 facts about the brain, it doesn't change you. But if I explain the process underlying even just 5 of your daily experiences, or what it means when you get tired, what that is, how to ameliorate that, what it means when you get stressed and how to deal with that. If I teach you the mechanisms that underlie those tools, then the tools are forever embedded in you. Now, one has to be very careful, because I always say the best case is where you can teach people something that it works the first time and every time, like sunlight viewing. In a 2-3 days, everything's changed if you're doing that consistently at the right times, or certain patterns of breathing for stress mitigation, or et cetera, or exercise for that matter. But you have to be very careful, because if you give people something with the promise that it works the first time and every time, and it doesn't, then you lose trust. So you have to build trust over time. And again, I don't know the proper language for this, but I think once people understand mechanisms, it must be the same way that physicians or psychologists start to see an interaction between 2 different people. And it's like those Peanuts cartoons. It's like wah, 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 chatter between the 2 of them, but it's the dynamics. And they go, aha, the algorithm is this. Here's what's going on here. Here's how to fix it. And I think we need a better understanding of algorithms, right? You're not going to teach somebody calculus by giving them showing them a problem set and a solution. You're going to teach them how you arrive at solutions to any problem set using a particular algorithm, more or less, right?
I had the greatest person who taught me some complex areas of calculus. Well, anyway, you know what? I'm not going to get into it. It's such a long story, but I agree with you completely that when you one way I think about it in calculus specifically is if you can come to understand things from first principles and never go into things where you have to memorize anything, the less you can rely on rote memory, the better. Well, it's been great sitting down with you and talking about this stuff. We, as I said, we covered a lot of stuff, and none of it is sort of what I had on my agenda, but that's not unusual for a podcast. I don't know how much you experience that.
All the time.
Yeah. You sort of go into it with some thoughts, and you get onto a tangent, and it's super interesting. And so I'm glad we got to spend this time together, and I look forward to sitting down and doing it again. Hopefully, like I said, it's just a great excuse to drag you back to Austin.
Yeah, I'd love to do it again. And I want to say thank you for being a mentor before you even knew it. When as a model and podcaster of how to handle oneself professionally in public facing role, and for the information you share, and now more formally as a mentor, because I call you all the time asking for advice in a number of different domains of life, whether you like it or not, and also for being a friend.
Yeah. Thanks, Andrew.